A confirmation about the audio, please, guys. If the audio is clear and available, kindly confirm. Thank you. I'm doing good. I hope everybody is fresh enough. Pranay, yesterday's earthquake in Afghanistan is due to continent convergence. Yes. The Eurasian and the Indian plate convergence, it is happening across that entire boundary itself. This year, lot of earthquake is in news, so can we expect a mains type of question? Maybe next year you can, but then I would argue that every year you have almost a similar kind. But then maybe next year, till the next year means there is a lot of time which is left. So you never know what particular issue might come into the question again. So, for example, the kind of a hostility which has broke out yesterday in the region of Gaza Strip around Israel. Now, that also, whenever these kind of hostilities break out, whenever you have such localized war which is in action, then locational factors are always asked in the prelims as well, about the regions which will share boundaries with the Mediterranean Sea and so on. So, like that, as you keep on following news headlines on a daily basis, automatically you would be aware of many of the newer areas to focus upon. But for that, you need to be focusing on current affairs. Pacific Ring of Fire, Ankit, basically all around the region of Pacific, there is some or the other form of convergence which is happening. That is either continental oceanic convergence or an oceanic convergence. Continental oceanic convergence you see in the case of the Nazca plate and South American plate, in between the North American plate and the Pacific plate, in between the Pacific plate and the Eurasian plate. And then you find the oceanic convergence between the Pacific plate and the Caroline Sea plate, Pacific plate and the Filipino plate. Now, because of that, whenever you have an oceanic convergence happening, there is always the eruption of volcanoes which happen across the plate margins. So all around the Pacific, not only do you experience significant amount of earthquakes and seismic activities, but also you experience very frequent volcanic activities. And that entire region around the Pacific, that is the Pacific Ring of Fire. Okay. Teesta River flood in Sikkim is important? No, not that much. You need to understand the larger aspect here, that in the Himalayan rivers, for in particular, why is it that the floodings are so frequented, especially whenever you have unusual amount of rainfall or cloudbursts? That is something, as we move ahead, we study the portion of Indian geography. Before that, we study in climatology about cloudbursts. We will cover the cloudbursts happening in the region of Uttarakhand as well, Sikkim as well. So the same template will apply to all of them. UPSC is never going to ask you that why a cloudburst happened in Sikkim, or why the Teesta River flooded. Such kind of question won't be framed. Japan has earthquake alert system. Can we implement in India? Yes, we can. But for that, you need better building standards, a better verification method as well, a systematic planning as well. Because when we take a look at the seismically active zones in India, the northern part of the country, that is very densely populated, and you have a kind of an inorganic growth in these urban areas where spacing is not there, where common open areas are not there. So if you have to implement it, you basically have to first of all bulldoze many of the existing houses and colonies, which I'm sure you would be aware is not a possibility, is something that will never happen. Akshay, yesterday I was asking about the Sikkim glacial disasters, and my question was that remains after disaster will also cause the normal faults. So that is what I was wondering about. That why are you asking about Assam mishaps? Yesterday also I told you it is not in Assam, but it is in Sikkim. But nonetheless, you have to understand that there's a difference between Assam and Sikkim. You cannot afford to do these kinds of errors. Okay, but then the thing is that once you have these cloudbursts or landslides, it is not going to trigger fault creation. Landslides can never have that much power to bring about faults or larger cracks in the earth systems. No. Because please understand that these landslides, these cloudbursts, probably now you have taken attention to the fact of these particular geographical events happening, but you have to understand that these are a common phenomena across the Himalayan region. And there is a reason for that. When we come to the portion of Indian geography, when we talk about Indian physiography, we'll address that question as well. That why Himalayas experience more landslides as compared to the Western Ghats. And this is one of the favorite questions of UPSC, which UPSC has asked multiple times in the mains examination, both for GS as well as for the optional area. We will address those generalistic areas. Okay. Deposition is basically when you have certain materials which are carried and then they are dumped in a particular area. That is deposition. Erosion is when you remove something from the original area. That is erosion. Let's suppose a river is flowing through the rocks, and the very slowly and steadily, grain by grain, particle by particle, the river removes some portions from the rocks. That is erosion. Now, those particles which have been eroded will eventually be dumped somewhere by the river. So, that is deposition. Okay. So, hello, a very warm good morning to all of you, and welcome to Baiju's Exam Prep IAS. Welcome to another session of geography, where today we shall be looking at the final module of geomorphology, where till now, we have largely focused upon the endogenic forces acting on the planet Earth. That is, the forces which have been acting from inside. As we talked about yesterday as well in the final moments, that basically all the forces which are acting from inside, partially triggered due to the residual heat which is still trapped in the interior of the earth. Now that can give rise to various features on the surface, in the sense that the endogenic forces, they can give about a rise of the land, where some portion of the land can suddenly be uplifted. It can lead to subsidence of the land as well, right? It can lead to expansion, contraction, tensional force, compressional forces, all of them which are acting on the surface. All of that we have studied, that is a part of the forces acting from the interior, and that is what we regard as the endogenic force. Simultaneously, at every point of time, you have the action happening on the surface as well, forces acting on the surface as well. That is initiated by the wind, the river movement, and so on. Now, those are referred to as exogenic forces. So, in very simple terms, endogenic are the forces acting from the interior, exogenic are the forces which act from the exterior. Now, this particular chapter is relevant for your prelims, even though this year in the mains examination you had a question from this chapter asked as well. So, here in the prelims, what can you expect out of this chapter is basically the aspect of weathering. What is it? Then mass movement, basics of mass movement. What is mass movement is something that we will study. Then landforms, agent of nature causing that or creating that landform. Responsible. Okay. In the mains, you can expect from this area questions to be asked from the portion of landforms, and also basics of weathering and mass wasting. Okay, so that is the portion which you can expect, or these are the topics from which you can expect a question to be framed easily, be it the prelims or the mains examination. So accordingly, you have to focus on that. Okay, now to give you a brief preview of it, when we talk about the various different movements, when we talk about the various different events happening on the Earth's surface, they are either because of the endogenic or the exogenic forces. Endogenic basically means forces acting from the interior. Okay, forces acting from the interior. And when we talk about exogenic, it basically represents the forces acting on the surface from outside by the agents of nature. Forces acting on the surface from outside. Okay, so that is the basic classification of the forces, the type of forces which act on any particular part of the surface. Either it can be forces acting from the interior or forces acting from the exterior. Now, in the case of forces acting from interior, we have seen that it can, again, I will reiterate, it can lead to the upliftment of the land where certain land mass, let's suppose if you have a land mass like this, now due to the forces acting from interior, there can be an upliftment of the landmass as well, where maybe this particular portion of the landmass over a period of time, let's suppose, rises or is uplifted maybe by 1 millimeter per year at that rate, or 1 centimeter per year. So, with that rate, after let's suppose thousands of years, you will find that the landmass is somewhat like this, in this shape. So, these are all based upon the forces acting from inside. Now, the forces which act from inside, they are also classified based upon how quickly they end up creating an impact, in the sense that they are classified into sudden forces and the slow acting forces. The slow acting forces, they are also referred to as the diastrophic forces. So when we say sudden forces, that is those kind of forces which are in action all of a sudden, which basically come into event immediately. For example, earthquakes and volcanoes. It is not the case that the volcanoes or the volcanic eruption in itself will take thousands of years to erupt. If it has to erupt, it will erupt almost immediately. Even earthquakes, for that matter, it is not as if the land is slowly moving and every day you are slowly shaking away because there is some earthquake which is happening. No, it is immediate. Earthquakes can last not more than 30 seconds or 1 minute, but that causes all the damage. So these are the sudden forces. Earthquakes and volcanoes, these are categorized into sudden forces which act all of a sudden. Diastrophic forces, on the other hand, these are the slow acting forces. Slow acting forces. Now, here, when we talk about diastrophism, diastrophism also is of two types. There is a further subclassification. So, just we have read all of this earlier itself in the form of the plate movement, the compressional, tensional forces, folding, faulting. We have studied all this. This is just the definition part of it. This is just the lineation part of it. So, diastrophism is a process of deformation that changes the Earth's surface. It produces many of the basic structures that we see on the surface, such as plateaus, mountains, and folds on the Earth's crust. Now, this further is subdivided into two particular parts. Now, here you can see that when the land, any kind of landmass, when it is acted upon in terms of the vertical or the horizontal movement, or even sometimes vertical movement which happens, that is basically a part of diastrophism, because many of the times you will observe that basically this is the landmass. Over a period of time, let's suppose this landmass has suddenly underwent a kind of a subsidence, or a landmass in between has suddenly indicated a kind of an upliftment. So that indication is basically because of these diastrophic forces. Now here, when we talk about diastrophism, diastrophism is further subclassified into aperogenic and orogenic. Now, both of them, they are both a part of endogenic forces themselves. And both of them being part of diastrophism means both of them are slow acting forces. So, aperogenic, what is the name associated? Continent building forces correlate to the vertical upliftment or subsidence of the land. So, any kind of event which leads to the vertical upliftment or subsidence of the land, in the sense that it is a slow acting force, that is regarded under the categorization of aperogenic force. Okay, also a slow acting force. So, this is also a slow acting force. Okay. This is also a kind of a force which acts very, very slowly over a period of time. And then when we talk about orogenic basically means what? Where you have compression or tensional force, which leads to folding and faulting. That can also create rift valley structures, mountains, block mountains, fold mountains, etc. Whenever you come across the term orogeny, orography, anything like that, it is mostly associated with the process of mountain building. It is mostly associated with the process of mountains or anything referring to mountains. So here, when we talk about the aperogenic, this is vertical movement of the landmass. Vertical movement of landmass. Right? In the sense that it can bring about upliftment or subsidence of substantial portion of the landmass. And it happens very slowly. Whereas when we talk about the orogenic, now this is basically a kind of a tensional compressional force which can give rise to folding, faulting events, creation of mountains as well. So that is the basic difference. This is the kind of a horizontally acting force. Horizontally acting force on the landmass. Okay, so that is basically a part of diastrophism. Diastrophism basically is a slow acting force which acts over a period of time, over a very long period of time, and it can give rise to various different shapes and features that you see on the surface, in the sense that it can basically bring about compression, expansion. It can bring about a kind of a sideways movement, parallel movement in the case of what we observe for transform plates, transform movement, etc. All of that is initiated by the process of diastrophism. So when we talk about endogenic forces, there are two basic classification: sudden forces, that is earthquakes and volcanoes, and slow acting forces, that is diastrophism. Within diastrophism, we talk about the land getting uplifted or subsided, and that is aperogenic forces. We talk about the forces which can compress or apply tensional force to the land, creating or giving rise to mountains, rift valley structures, etc., or folding and faulting which is created. That is a part of orogenic. So both of them, that is aperogenic and orogenic, they are a part of the diastrophic forces. So this is the basic classification of the endogenic. But when we talk about the exogenic forces are basically also referred to as the levelers, as we have talked about this earlier as well. That why are they referred to as levelers? Because exogenic forces which are acting on the surface, so let's suppose in any place you have any amount of undulations which are present on the surface, any amount of variations which are present in the surface, wind action, river action, glacial action, all of them, they will be acting on these protrusions, undulations, and they will try to basically level them to the ground. So basically have a kind of a same topography on the ground, a kind of a featureless surface. So that is the action of the exogenic forces, or that is the consequence of the exogenic forces. Now, these exogenic forces basically are also divided into different categories depending upon what kind of action does happen. For example, you have weathering. What is weathering? Weathering is when any larger rock type, when I say larger rock type, it can be a large rock extending for hundreds of meters altogether, right? The large parent bedrock or the crustal surface extending for hundreds of kilometers of the rocky areas. Now, when they get broken into smaller parts, many smaller subparts, that is the process of weathering, and they get broken because of the events of the chemical action, because of the events of the biological action, or the physical action as well. So accordingly, you have the classification into physical weathering, chemical weathering, as well as the process of biological weathering. So weathering also basically is breaking down the rocks, changing the surface of the planet, or changing the characteristic of the surface. Now, that is acting from the outside, and hence it is classified as an exogenic force. Whereas then when we talk about the mass movement, what is mass movement? So the name again is self-explanatory in this case. When you have movement of materials or mass, or in large bulk, the movement of materials happen because of the presence of a slope, or because of huge volume of water which is present, any of these, creating landslides, creating rock fall, debris fall, mud flow, earth flow, any of these, that is mass movement, where together you have a bulk of material which come down the slope. So here mass movement can happen slowly over a period of time, for example creep and solifluction, or it can happen very quickly, for example landslides, earth flow, mud flow. These are the mass movement activities. And then the agents of nature, such as running water, then glacier, waves, winds, and also when we talk about the action of water, underground water, and even surface water, which can react with the rock surface, creating various different types of landforms, that is the erosional and depositional landforms which get created. So that is basically the aspect of exogenic force. Earth flow, see, when you talk about the mass movement is basically classified into three types, that is fall, slide, and flow. That is the basic classification. Now, what is fall? So let's suppose you have in a particular area, let's suppose you have the presence of rocky regions, right, with a great slope. Now, here, if the rocks, let's suppose they become weaker, they will not require water to allow them to flow. So they will simply fall down, right? So rocks, debris. So this is fall. This is referred to as a rock fall, debris fall, etc. Okay. Many of the times while you move through the mountainous areas, when you drive through the mountainous areas, you'll see the warning board that debris fall and rock fall region. So beware. So that means from that mountainous area, from that slope, you can expect the rocks to suddenly roll down or fall down because they are loose and they cannot be held back together. So they end up falling. So that is the part of fall, right? Then when we talk about slide, so when you have a kind of a slope, let's suppose whenever you have the kind of a slope, somewhat like this, okay, and there is excess amount of rainfall which has happened, sudden excess amount of rainfall. Now, that huge amount of water, what it will do is it will, in a way, start liquefying the soil, because that excess amount of water will not only create a kind of a muddy situation, but it will create that kind of a slide as well, where the entire slope becomes unstable and this portion simply gives way, right? And the rest of the portion, they also slump. So that is a slide. So slide is also landslide, earth slide, mud slide, depending upon what amount of materials they come along with that. Right. So when we say mudslide, only some amount of muddy nature of materials you will find coming down the slope. When we talk about earth slide, you will observe some amount of rocky substances also come down the slope in case of heavy rainfall. When we talk about landslide, then the entire land in itself that starts sliding off. So that is the portion of slide. And when we talk about flow, flow is basically when you have too much of water greater than even the case of the slide. So in the case of a flow, it is almost liquid and a liquefied movement of sorts, because that much excess amount of water is there that it will start forming a kind of a solution with the soil particles, and that will start flowing. So that is again categorized into mud flow, earth flow, debris flow, depending upon what kind of materials are carried by them. Okay, is that understood, Akshay? So can we call the stones flowing in rivers like Ganga from Gomukh Glacier as the process of earth flow that we normally see in Haridwar? No, absolutely not. So the rocks that you see moving across with the rivers, that is very much a part of erosion itself, where the rocks will erode something from, where the river will erode something from a particular larger rock. It will be broken into smaller parts, and the river will carry it away. That is a part of erosion, right? Slide and flow and fall basically is a category of mass movement. Mass movements are not initiated by the river action. Mass movements are initiated due to the slope characteristic. When the slope is significant due to the force of gravity, and if you have excessive water, materials will start sliding down. So that is the part of the slide. It is very different. Muddy slide we can observe in Udupi, Kodagu. Kodagu, yes. Kodagu, you will observe a lot of them. Then, for example, in when you're talking about southern part of the country, Parshuram, you will also observe it a lot more in the region around Munnar, in the region around Wayanad. In these areas also, you will experience a lot of slides. Okay. Solifluction, I'll come to it. Don't worry. Difference between erosion and weathering. In the case of a weathering, if let's suppose you have a larger rock, this rock will be broken into many small particles here itself. Okay? By the outside actions and events of nature, this larger rock will be broken into subparticles here itself. That is weathering. When we talk about erosion, let's suppose you have a larger rock. Now, in this case, if a river is moving nearby, the river basically starts plucking small particles one at a time, and then it carries it up over. So that is erosion, right? Slowly and steadily removing it. That is erosion. So erosion, in that you carry the materials, you basically lead to the degradation of materials here. You carry the transportation is involved, and then deposition is involved. In the case of weathering, you have the in situ breakage of rocks which happen. Okay. Now, then here, when we talk about each of them separately, so weathering. So weathering is basically where the rocks in situ or in their original position, they are acted upon by the outside agents of nature, such as, let's suppose, heating by the sun, very cold conditions during the night, chemical actions, biological actions, and that leads to the breakage of the rocks in their original position where they are found. Okay, in that region itself, that is basically what is weathering. So, in the original position of the rocks, right? Or simply, it is the breakage or the breaking of larger rocks into smaller parts in the same region due to external forces. Okay, so that is weathering, where in the same place, wherever the rocks are to be found, in the same place, the rocks get broken into many small parts. For example, the soil that you see around you, that soil has been created because of the breakage of the rocks, right? Or because of deposition or erosion action. But in majority of the areas, the soil that you find is basically created as at one point of time, millions of years back, those regions would have been covered and would be present or would have consisted of only rocky surfaces. And because of the events of climatic changes, because of events of chemical biological events, you would have those rocks breaking into smaller particles, those smaller particles further breaking down, and then you have the presence of fine particled soil that we see. Okay, so soil is also a byproduct of the process of weathering. But how does the process of weathering happen? So weathering is about the breakage of the rocks in their original position, where the subparticles are also present in the original position itself. So it is classified into physical, chemical, and biological weathering. So when we talk about each one of them, physical weathering, for example, what is physical weathering? So here the breakage happens because of the agents of nature such as sunlight, such as heat, cold conditions, rainfall, etc. That leads to the breakage. For example, let's suppose here you have a larger rock part. Okay, let's suppose. Now, during the case or during the summer condition when there is excessive amount of heat, just like any other substance, this particular rock will also, due to getting heated, this rock will also exhibit some amount of expansion, right? If let's suppose there is excess amount of heat, it will indicate some slight expansion, very slight though, but slight expansion. Again, during the winter months when it is very very cold, it will indicate some amount of contraction. Again, during the summer, again slight expansion, again slight contraction in the winter. Now let's suppose this process carries on for hundreds of years. Now in that process, the rock, because of continuous process of expansion and contraction, that will indicate a kind of a development of a crack. So it can lead to the development of a crack because of that. Okay, let's suppose a crack like this has developed. Now then, let's suppose we talk about a region where it rains during the winter as well. So in that area, when it is raining, when there is rainfall which occurs, then some amount of the water will also percolate and get pushed into these cracks, isn't it? Water gets pushed in and fills up these cracks. You would have seen many of the rocks where water fills in the cracks. Now, in that situation, when the water fills in those cracks, then what happens during the winter months? Let's suppose during winter, when it is suddenly going to be very, very cold, then what do we expect? So, all that ice, all that basically the water which was present, all that water will get frozen immediately, isn't it? Because when you have the water during the cold months, it will get frozen. And then frozen water, that is ice, occupies a slightly larger volume as compared to liquid water. I hope we are all aware that ice occupies a slightly larger volume as compared to liquid water. So here, the rainwater which was accumulated, let's suppose this gets frozen. So as it gets frozen and gets converted into ice, it will expand ever so slightly. So when the ice expands ever so slightly, what will happen to the crack? The crack will further deepen. Maybe it will have some extension like this. Because of the weaker structures, the cracks will deepen. Now, when the crack deepens, means in the next bout of rainfall, there will be more water which will fill it up. Again, during night, let's suppose it freezes. Or during winter months, let's suppose it freezes. Again, it will carry out a kind of an expansion. Again, the cracks will deepen. Meanwhile, during the summer expansion, during the winter contraction is happening. So due to these processes of heating, cooling, freezing, melting, you will find that the cracks eventually deepen so significantly that they will lead to the complete breakage or the breakdown of rocks into many smaller particles. right? So that is a breakage or a weathering, the breakage of the rocks happening in its own original position because of the agents of nature, because of the action of the nature from outside, such as heating, cooling, freezing, melting, etc. So that is the physical weathering, where the physical structure of the rock is altered because of the phenomena or the agents of nature out there. So created due to, or basically events of breakage due to expansion, contraction, freezing, or melting. So, when the breakage of rocks happens because of these events or these activities, that is the physical weathering, where the physical structure has been compromised and the rocks will break into smaller parts due to that. Now, then you have the chemical weathering. Now, name in itself tells you how melting. So, basically, if suppose water has entered here, and when water has entered, then during the winter months, let's suppose the water gets frozen. During the winter months, as the water gets frozen, it will expand because ice occupies a larger space, so it will expand. The cracks will open up, the cracks will expand. Again, during the summer, the water will melt, so that means now you have a more space available for more water to come in, so more water will come in. That will again expand during the winter months due to freezing. Again, during summer, that water will melt. Is that understood? Okay. Now, then we come to the portion of chemical weathering. So, chemical weathering is where the breakage happens because of the chemical actions. For example, many of the times, even the rainfall which occurs, the rainwater is slightly acidic in nature. Now, that rainwater, sometimes in the case of seawater as well, but mostly in the case of rainwater, you will observe that when you have that rainwater entering within the cracks and crevices of the rocks, let's suppose the rocks are made up of certain materials which are soluble in water. Let's suppose the rock is made up of a material like calcium carbonate. Now, calcium is soluble in water, isn't it? So, here let's assume that there is a crack which has developed due to the physical weathering process. Okay, and this is an area where there is in the rock significant amount of calcium which is present. Let's assume calcium carbonate. Now, as the water starts getting pushed in through these cracks, water as it starts filling in these cracks, slowly and steadily over the years, water will enter into the region of the calcium carbonate. Then there will be a chemical reaction between water and calcium carbonate where water will start dissolving them. Okay, it will turn into a kind of a whitish solution as water starts dissolving the calcium carbonate. Now that process will continue for maybe few tens of years or hundreds of years or thousands of years, depending upon how large a rock are we talking about. But eventually water will be able to make its way through. It will hollow out the entire region here, and as it hollows out the entire region, then this portion of the rock will be left without any support. It will break. But this breakage has happened why? Not because of physical weathering, but because of a chemical action or chemical reaction between water and the materials which can be soluble in water. So that is how you basically observe the chemical weathering taking place, where the chemical events or the chemical action, they lead to the breakage of the rocks by dissolving certain materials which are present in the rocks. So here breakage happens because of chemical actions between mostly water and materials within the rocks Yes, Parshuram. Within the rocks, which are soluble in water. So that is what leads to what we refer to as the process of chemical weathering happening or spanning out. So that is the physical and the chemical weathering. What do we mean by biological weathering? So for biological weathering, you have the role played by the biological agents of nature, for example, plants and animals. They also help in breaking the rocks. Now, for that, before thinking about it, I want you to associate again, relate with a real life example. Any of the older buildings that you would have visited, especially older government houses or older government buildings, many of them are abandoned. Now, if you would have observed them, you would have observed, I'm sure you would have observed that in certain cases, there is the growth of plants, for example, from the walls themselves. You'll find that from the upper, in the region of the ceilings of the walls, or where the junction between the roof and the wall is, there you will find certain small plants growing. If it is not tended to immediately, then you will find the larger plants that grow, they will multiply in number, right? And if that continues for a very long time, you'll find eventually the wall in itself will break down. Now, why has that happened? Not always lichens. You have, for example, in certain cases, even trees such as banyan tree starts growing within these walls. So in that case, it is always said that get that tree out, get the roots of the tree out, otherwise the entire wall structure will break. So why does that happen? Because when we talk about rocks, rocks also consist of various different minerals, minerals which are required by the plants to grow, right? So let's suppose you have a rock where you have development of a kind of a crack. Now, within that crack, slowly you will have initially seasonal plants which will grow. Okay. After a couple of seasons, more plants will thrive. You would have seen this as well in your real life, that a larger rocky structure, there is small gap. In that gap, multiple plants will be growing. This bigger gap, you will have many plants growing in that region, isn't it? Now, if that happens, now always the plants will have roots. Now those roots, they will start extending within those cracks slowly and steadily. They will be expanding those cracks in search for nutrients. And wherever such plants are there, naturally insects and rodents will also come. Various different rodents, burrowing animals, they will also come. They will try, because they get access to food, they will try to make this their home. Now, when they carry out those burrowing exercises, that will be very small, very minute. But over a period of time, it will weaken the rock structure and it will expand the crack as well. So maybe after that, you have a more larger plant which grows here, more animals which come. So this will lead to the expansion of the cracks, and eventually it can lead to the breakage of the rocks. But this breakage of the rock has happened because of the biological action taking place, in the sense that you have the life form inducing the breakage of the rocks by the plants and the animals inhabiting that area. So the next time when you visit any of the old dilapidated buildings, the government buildings, mostly government offices or the government colonies, for example, you still have few of the older, almost in every part of the country, you will find those older government buildings and government houses. You'll find that on the externalities of these old houses, where proper maintenance is not done, you'll find few of the saplings, few of the small plants at the level of the small shrubs, they start growing from these walls. And if immediate care is not done, if immediate repair or maintenance is not done, it will start breaking the walls. First of all, the outside plaster starts getting weaned off, and then after that, the bricks, they start getting weaker. Why is that? Because as the roots basically start spreading very slowly, they will weaken the structure, and then the animals come in, the birds come in, they will further enlarge that crack and will lead to the breakage. So in either of these cases, breaking will happen, right? Yes, bridges and flyovers also are a common site for this. So in either of these cases, breaking of the rocks will happen. But that breaking can happen because of the events where the physical structure in itself is compromised due to heating, cooling, melting, freezing, or because of the fact that you have a chemical reaction where, let's suppose you have materials such as silica or carbonate, any of them which is soluble in water. Now when that is dissolved, the rock becomes hollow from inside or simply breaks open, or biological events. But out there in nature, it is not the case that this rock has been broken only because of physical weathering. This rock has been broken only because of chemical weathering. And this rock has broken only because of biological weathering. That is not the case. That means out there in the nature, you have the simultaneous events taking place. Simultaneously, the rocks will be broken into many smaller parts. Okay, this is an event which happens simultaneously in the nature. It is not the case. So out there in the nature, what happens is that physical action or the physical agents, they will weaken the rock structure, create a crack. Water will enter, it will start forming a solution with the materials there. Now in those materials, you will have plants also which will grow, and a combined action or a combined event of all these three can lead to the ultimate breakage and the weakening of the rock structure. So that is what we refer to as the process of weathering. Okay. Now, from weathering, we move on to the portion of mass wasting or mass movement. So, mass wasting or movement basically is, this is also what is mass movement. Now, what is it? So, when we talk about mass movement, we are talking about bulk movement of materials, always aided by gravity. Okay, always aided by gravity. Mass movement will never happen in a surface without a slope. Always it needs to have a slope so that the gravitational force will act upon it. Okay. Now, influence of gravity is the one which will pull down in bulk materials at one point of time. At one go, bulk materials will be pulled down. Now, as I told you, depending upon whether it is directly vertically almost falling, it can be categorized into fall, or if you have large portions of the land simply moving away, it can be a slide, or let's suppose excessive water leading to a kind of a liquid flow of mud, earth, materials, etc. That is what is referred to as a kind of a flow. So that is the categorization. But this mass movement is dependent upon the slope feature, the volume of materials which are available to move, and also the volume of water which is available. So here, for example, volume of material. So let's suppose in any of the hilly areas or mountainous areas, let us assume now you have lot of soil, topsoil, without any vegetation. And when I say without any vegetation, in the sense that there is nothing out there to bind the soil together. Okay, so the topsoil is absolutely loose. So when you have a very loose topsoil, then what will happen? So in case there is excess amount of rainfall, right? And let's assume all of this is loose topsoil without any vegetation. So all those materials are free to move. So the movement which will happen will be quite significant, isn't it? So greater the volume of material which is available to flow, greater is the movement which will happen. Then about the water content as well. Well, let's suppose the water content availability is less. How do we get that water? When we talk about repeatedly about the water content, availability of water, etc., from where do we get that water? This water that we are talking about, we get it from precipitation, that is rainfall, melting of snow, etc. So this water is gained by rainfall or precipitation, melting of snow, etc. Now, all these activities, what do they lead to? So, let's suppose here you have two conditions of slope, two different types of slope, let's assume. Okay. In one of them, that is A here, you have very little amount of rainfall, right? In the other one of them, now let's assume the volume of material is same. In other one of them, you have huge amount of rainfall caused maybe due to a cloud burst, etc. And very heavy amount of rainfall occurs here. So obviously, in the second case, the materials will have an easier time to move. More materials will be able to move in the second case because the volume of or the availability of water is more. So when you have a greater availability of water, that also induces that kind of a movement. When you have lesser availability of water, then the movement is also slow, right? It is also going to take a lot of time period. Okay, so here, greater availability, higher water content, availability means faster flow and more materials carried carried over. Okay, whenever you have lesser availability of water, then less materials will flow and it will take a lot of time. For example, creep is something that we'll take a look into. So in case of creep, the availability of water is almost negligible, so it happens very slowly, maybe 1 centimeter a month or somewhat like that. But in the case of a landslide, when you have a cloudburst event, etc., landslide is triggered immediately. Why? Because the volume of availability of water is very, very high. Okay, so that is how water availability and the content of water also influences the type of mass movement and the kind of mass movement which will happen. Then the steepness of the slope. Steepness of the slope is the one which will influence the gravitational force of attraction as well. Because let's assume there is a lot of loose material which is present, there is lot of water also which is present, but let's assume the ground surface is flat. Will there be any movement? No, it will form a puddle, it will form a muddy region in this place itself. There won't be any movement. But attach some slope to it. Immediately, all the materials will start moving down. If the slope is increased, the rate of movement increases. If the slope characteristic is further increased, then you will come across the condition of a fall, where even without water, the materials will slide down. So, greater the slope, that is, if the slope is very steep, you will have not only will you come across more materials coming down, but coming down at a faster rate. So that is the characteristic of the slope, because gravity, in a sense, the gravitational force, the vertical aspect of gravity, that is much more active when you have the slope characteristic. So higher the slope or steeper the slope, faster is the movement. Okay, so that is the case of mass movement. Okay, now why mass movement don't come under erosion, though there is a shift of materials from one place to another aided by gravity? Because transport, see, erosion, you can categorize it as well as erosion, but is any material really getting eroded out of it? If you don't have the available materials, or have you come across the situation where, let's suppose, across the slope you only large rocks, no soil? Will there be mass movement in this case if all the rocks are bound to the surface? No. If there will be rainfall, some materials will be accrued from there, right? So that is, erosion is where slowly and steadily materials are removed. That is why the name mass wasting or mass movement is associated here, that it is not a regular phenomena. It is not something which happens minute by minute, hour by hour, but at one go you have lot of materials which are taken away, and taken away, they are immediately slumped at the bottom there, right, aided by gravity. But in the case of erosion, let's suppose if you had a rocky surface and there would be rainfall, continuous rainfall. Now, due to that rainfall, some amount of that rocky surface is carried by the rainfall, and in the seasonal streams, it basically carries it over. So that will be a part of erosion. But when we talk about mass movement, we are talking about the bulk movement of available materials. We are not talking about the existing rock type, some portion of that will be eroded during the or removed during the mass movement. No, only the materials which are available to move, only those materials will move. Right? Have you come across a rocky mountain where everything is made up of hard rocks? There is no such loose material. Will there be a landslide in that area? Absolutely not. It will only happen when there is loose soil on top of the mountain, which is available to move. Is that understood? It was a question by Peda Boyner. Is that understood, or is there a doubt which still prevails? Let me know. Kedarnath floods 2014. No. Kedarnath floods 2013. 15th of June 2013 is when the Kedarnath disaster happened. That is the example of landslide and initiated by the cloudburst. And then, Peda Boyner, you had another question, that why weathering is not a prerequisite for mass movement, though it aids mass movement. It is never a prerequisite. For example, let's suppose in a particular area, you have a slope characteristic like this. Let's assume. Now, here you have certain loose rocks which are there. Now, if these rocks have to fall, for that, do they need to get weathered first? No. If let's suppose across the slope, you have a lot of loose soil which is present and there is rainfall. There is a lot of rainfall. There are some larger rocks as well embedded within them. Now, if there is rainfall, all these materials will be carried over. Is it because of weathering event? No. Wherever loose materials are present, they will move over. So weathering can accelerate the process of mass wasting. Weathering can always, in a way, increase the amount of materials which will move in mass wasting, but it is never a prerequisite. It is not as if weathering event is not happening in that region, it will the mass movement will not happen. Is that understood now? Okay. So now we take a look at certain examples of mass wasting. For example, landslide, solifluction, creep. Now what they are. Now, if you take a look at each of these images, they all indicate some or the other form of mass wasting. The first image is that of a landslide. In the case of a landslide here, if you will observe that the water content would be so very high. You would, if you would take a look into the image carefully, you would observe small streams of water also flowing through. So that is where, along with the materials, you have streams of water which also end up flowing through the region. Right? So rocky materials, soil particles, everything which is loose, which is free to move, that is going to create a kind of a landslide. Okay, so when we talk about a landslide, it is defined as a movement of a mass of rock, debris, or earth down the slope. It can be initiated in slopes already on the verge of movement by rainfall, snow melt, changes in water level, stream erosion, changes in groundwater, earthquakes, melting of snow and ice, everything, volcanic activity, disturbance by human activities, all of them can induce landslides. All of these actions or any of these actions can end up inducing a kind of a landslide. Now, earthquake, shaking, and other factors called also. So, for example, let's suppose when we have underwater region, if there is an earthquake underwater, that also induces landslides underwater in the sea mounts. In the various sea mounts, also you can experience landslide. You can also experience landslide in the region of the continental slope. What you observe in the water body, the slope of the land is somewhat like this. So there also you can experience a landslide. So landslide can also happen underwater. Okay, landslide can happen. Generally, we observe the landslide in the mountainous areas, in the hilly areas. In Western Ghats, you observe a lot of landslides. Himalayas, you experience a lot of landslides. So that can also happen underwater. This is a faster movement of materials. So this is where you have faster movement of materials. Movement of materials. And why does that happen? Why is it that we have faster movement of materials? Due to high amount of loose materials and also high amount of water and availability of loose materials. Okay, so that is why landslides are initiated. Generally, in our country, you would observe in the Himalayan region, even in the portion of the Western Ghats, that landslides are accompanied by whenever you have very heavy rainfall, very heavy and sudden rainfall, then landslides occur. But it is not the case that, and one thing, if you would have noticed, if you have ever been stuck during a landslide, if ever you have or if you belong from the hilly areas of the country, you would always associate with that. When it is raining, rarely will you experience landslides happening at that point of time itself. Generally, you would find the case that, let's suppose this is the slope. If, let's suppose, there is a continuous rainfall for the past 2 days, right? Continuously it is raining. So all that rainwater will start percolating. Some of that will start flowing as well. Now, all of that will start percolating. It will start loosening up the soil, right? The next day, or even immediately when the sun again shines over. Now, when the sun shines, that is when all these materials, they basically, in a tendency to dry out, they get disjointed from the base. And that is when the movement happens. So this is something that you would observe from practical experiences, that landslides generally happen after the rainfall has basically abated or come to a stop. Immediately when the sunshine happens, that is when it is very, very dangerous. So the common perception is that if it is raining, immediately there will be landslide. No, but immediately after rainfall, the next day, if it is very bright, sunny condition, that is a condition very conducive for landslides happening, because that is when the soil from the bottom itself will get disjointed as the water starts evaporating. And then the entire material is free to move, because already there is so much water content, the entire material starts moving down with a certain kind of intensity. Something that you observed this year in Himachal Pradesh as well, where you had so much amount of landslides happening, so frequent amount of landslides happening, that was happening because of this. So this is something that you would experience on a day-to-day circumstance. Okay. Now, sea erosion is an example of slope steepness. Which sea erosion are we talking about? Erosion is different, my dear friend. Again, I will say, erosion is different from weathering, is different from mass movement. If it would have been the case that erosion and mass movement, or erosion and weathering, would have been the same, I would not have talked about it in different headings. I would have talked about that, okay, erosion happens, large amount of materials are carried away in landslide. Erosion happens, small amount is carried by the river. Please understand, erosion is what? Slow and steady removal of materials from a particular area. That is erosion. Okay, erosion is aided by materials or the agents of nature, such as, let's suppose, rainfall events, such as, let's suppose, when we talk about river movement, glacier movement, wind movement, or the movement happening due to the sea wave action on the on the coastline. So that is where slowly and steadily materials are removed. One particle at a time, materials are removed. That is erosion. Okay. When we talk about weathering, in bulk, the materials, they get broken down in the same place. They are not carried away anywhere. They are broken down in the same place. That is weathering. When we talk about mass movement, in that, bulk movement of materials happen at one point of time. It is not a continuous thing. It happens at one go. And that is when the bulk movement happens, aided either due to gravity, or due to excessive rainfall or snow melting, or whenever you have loose materials in the presence of a slope, it will simply accumulate at the slope. slope bottom. So that is why erosion is very different from weathering. Erosion is very different from mass wasting. Mass wasting is different from weathering. All of them are different. Apply your normal logic. If all of them would have been the same, why would I have covered this under different headings? Wouldn't I have covered that, okay, there is exogenic force, materials are removed? Please understand. Is there something which is still in doubt now? Anybody having doubt between erosion, wasting, and weathering? That if this is another form of erosion, if this is that kind of an erosion, is there any kind of doubt in that? Volume of materials refers to the availability of loose materials which can flow, right, which can move. That, so in regions where, let's suppose, you only have bare and barren rocks, there those rocks which are bound to the surface, they are bound to the internal rock structure, they cannot move. So in that case, regardless of the high amount of rainfall, there won't be any mass movement, right? There might be some particles of the rocks carried away here and there, but there will never be the case that very large boulders of rocks which were earlier affixed with other rock particles which were a part of the larger rock, all of them started moving due to rainfall. No. So volume of materials here refers to availability of particles which can move under the influence of gravity, such as loose soil. So even in the slopes which are densely forested, you don't have many materials which are available to move, because the trees, they will bind the soil by their roots. Okay, so even there you don't have the case. But then when, let's suppose, you have a kind of a barren soil surface on the slope, there in the slightest amount of rainfall it will start moving. So that is basically the importance of volume of material. Is that understood? Coastal erosion. So kindly wait for some time. We'll come to the portion of the action of the sea waves, and we'll talk about the coastal erosion there itself. Okay, we'll talk about that, how the coastal erosion creates sea cliffs, etc. We'll talk about the action, but this is very different, guys. Erosion is not at all same to weathering. Erosion is very different from okay, let me do one thing. I cannot be repeating the same thing endlessly. I guess many of us are so very used to, from our very school days, to look at the table, rote learn the table, that okay, this is the difference where we say that material is moving, in this material is not moving, in this that much material is moving, in this little material. So I think that is the approach we need to follow here. We need to go back to that kind of approach, pedagogy of school days, where we talk about the tabulated form. River movement, wind movement, glacial movement, action of underground water, C action. Continuous process. Materials removed are transported over a long distance. Mass wasting is when you have bulk movement of materials happening due to slope. There is a need to have how can mining be a mass movement, my dear friend? How can please elaborate this. I'm very interested to know. How is mining a mass movement? How can what is a mass movement? What do you understand by mass movement? If it is not clear, please feel free to ask. What do you understand by mass movement? It is made up of two words: mass, movement. When you have movement of large mass of materials, that is mass movement. In the case of mining, do you observe that there is a natural movement of materials? Is that the case? No. Is there any kind of mining activity in which you will find suddenly large mass of materials moving automatically? No. Then how can you akin it to the mass movement? If you just have to basically form an analogy in any kind of thing, then you can ask a question that is mass wasting, is war a kind of a mass movement? Because there also you have large number of people moving at one go. So can we think war as a mass movement? Can we think Indian railways as a mass movement? Because there also we are carrying masses. So please understand what is mass movement. Mass movement, again, take a look at the definition of it. Hold your horses for a brief moment. Movement of rocks and soil down the slope under the influence of gravity. Under the influence of gravity, I've circled it around as well. So that is mass movement. When you have bulk of materials moving down under the influence of gravity. Gravity is the catchphrase here. If the land would have been flatter, all those materials would have never moved. If they only because there is a slope, that is why the materials come sliding down, that is why the materials come flowing down. That is why it is referred to as a mass movement, because in bulk you will have lot of materials coming down the slope. That is why mass here does not refer to any weight, large bulk of materials which come down. Otherwise, if we have to form an analogy, we can virtually form analogy with anything. The bus, the state transportation bus is also a mass movement carrying a large mass of people. The railways, the airlines, all of them are mass movement. But is that the mass are we talking about? We are talking about basically the large bulk which is carried under the influence of gravity. Now, in the case of mining, where do you see that action having? Where do you see that event unfolding? And in the case of erosion, that is something which is very different from mass movement, very different from the process of weathering. There's a need to have availability of loose materials like loose soil, which can move readily down the slope. Presence of rainwater facilitates that bulk movement. Weathering is something which is very different, where you observe large rocks getting broken down into many smaller parts, which, due to action of heat, cold, freezing, chemical action, biological action, etc., happens in the original position of the rocks. Is that understood now? That erosion is not mass wasting, erosion is not weathering, or rather, mass wasting is not erosion, weathering is not mass wasting, weathering is not erosion. Is that understood, or do we have any doubt, any kind of doubt? Please ask. Loose soil area, we can refer to deforestation affected land also, right? Yes. Yes. Glacial bursts or landslides are also type of mass wasting. Yes, my dear friend, here we have taken the case of landslides as a part of mass wasting. Weathering, the last point is that weathering will happen in the original position where the rocks are to be found. The rocks need not be carried away somewhere. You need not erode that. So if you have a large rock surface here, here itself it will get broken down into many smaller subparts. That is weathering. Any doubts that we have? After weathering, it can help in mass movement, yes, but weathering is not a prerequisite for mass movement. Weathering can always accelerate the mass movement, but it is not or never a prerequisite. Now, if we come back here, basically, that we've had been discussing about landslide. So when we talk about landslide, it is a faster mass movement where you have a larger availability of water, and generally when you have a lot of loose soil which is ready to flow, that is when the landslide occurs, right? So generally accompanied whenever you have very heavy rainfall, cloud burst events, in those cases you experience landslides in action. Then we have a slow mass movement, which is very slow in its action, that is creep. It is a very slow movement. So many of the times you would have observed, uh, in case you have not observed, in regions of gentle slopes, sometimes it is observed that the, let's suppose the fences which are there, even the poles, electric poles, telephone lines, all of them, the installation that you see, over a period of time, you will observe that they indicate a slight bending in a certain direction. They indicate that all of them, they may be bent in a certain direction. So that is something which is induced due to the movement of the soil underneath them. Now, that is creep, where the slope is not very steep. If the slope would have been very steep, all the loose materials would have readily flowed down, where the availability of water is not very high, because if the water availability would have been high, it would have generated a kind of a flow, earth flow, mud flow, debris flow, something like that. So it is not a kind of a steep slope. It is not a high availability of water, but very slowly and steadily, the materials, they keep on sliding down. So the slow movement can be 1 centimeter, 2 centimeter per month, or even slower than that. That is why in the cases of slightly sloping areas, you will find that even the boundary walls, the fencing, even the trees, sometimes they will indicate a kind of a bend. I'm not talking about those electric poles that you see on the roads which are completely bent over. That is a pure case of infrastructure damage. I'm not talking about those, but all of them, when they indicate a kind of a bend. For example, the image that you see here, so here you will observe that all of them are bent in a direction indicating that the movement is happening. Very slow movement of topsoil along with subsoil is happening in this region. So here, the very gentle slope, very gentle slope, little availability of water. Okay. So in that case, you have a very slow movement happening over a longer period of time in the region of the soil portion. That is referred to as a creep. Creep is something that you will experience in almost all parts of the country. It is not something which is restricted only to a certain physical topography. It is something that you will observe anywhere where you have a gentle slope. So the slope should be gentle. If it is steep, you will have a kind of a fall, debris fall, rock fall, etc. But here you have a very gentle slope. Gentle slope basically means where it is, so steepness is this when the angle is very high. Gentle is when the angle of the slope is very less. That is referred to as gentle slope. I'll write it down here as well so that it doesn't create any doubt later on. So angle of slope is very less. Is very less. That is creep. Then we have solifluction. Solifluction is what you observe in this one. Now, here, if you take a look at the image, the soil in itself indicates a kind of a development of some amount of a flow of sorts, as if it is a liquid, right? The soil, if you observe here, you will basically observe that there is a kind of the flow pattern developed in the soil, hence solifluction. Now, why does this happen? Where does this happen? And where do we observe this? So, generally observed in the regions of permafrost. So, permafrost, again, a term that you have come across for the first time. So, permafrost is basically those areas of the planet which are permanently frozen, right? At least the subsoil is permanently frozen. So when we talk about the regions of the higher latitudes, closer to the polar areas, when we talk about the regions of high altitude, that is great heights, in all these areas, the soil, the subsoil is in the state being permanently frozen. Now, in those areas of permafrost, sometimes during the summer season, the topsoil becomes free of ice, but the subsoil is still frozen. So understand that when we say permafrost, we are talking about a region where the topsoil is sometimes, let's suppose, ice free, but the subsoil is perpetually or permanently frozen. Now, in these conditions, when the summer comes, when the topsoil is basically free of ice, the topsoil, in the presence of melt water, starts moving, starts flowing almost. That is what is solifluction. It is a slow movement nonetheless, but it indicates a kind of a move. So that is what is solifluction. So this is observed in the regions of permafrost. Observed in areas of permafrost. That is permanently frozen areas. That is generally found in higher latitudes. That is northern part of Eurasian continent, that is in the polar regions, and sometimes in high altitudes, but mostly in high latitudes is where you find them. Now, during the summer season, summers, as the topsoil becomes ice free, as a result of that, basically you will observe, as the topsoil in itself gets rid of the ice formation, but the subsoil is still frozen. Subsoil is still frozen. So, in the presence of melt water, so imagine if this is the subsoil. Subsoil means the layer immediately below the topsoil. So, if the subsoil is frozen, the topsoil becomes ice free. So, both of them will lose the coupling or the kind of a connection. In the presence of melt water, the topsoil starts sliding down in a kind of a flow pattern, that is solifluction. Okay, so in the presence of melt water, the topsoil indicates a flow. That is what we regard as solifluction, generally observed in places of higher latitudes. Observed in higher latitudes, closer to the poles, and higher, and sometimes, very rarely, in higher altitudes. So the regions of permafrost are what? The regions, for example, northern portion of Canada, Greenland, for example, the northern portions of Europe, northern portion of Russia. So those are the areas which are regarded as permafrost, where the subsoil is permanently frozen because of lower temperature. There, even during the summer months, it is not going to be the case that the temperature in summer is 30-40 degrees Celsius. Even during summer, the temperature is 5 degrees 6 degrees Celsius. So that is not enough to melt the subsoil. Okay, so the warmer condition during the summer can melt the topsoil or melt the ice on the topsoil, but the subsoil, that will still remain frozen because generally it is colder. Okay. Pavni, can weathering and erosion occur simultaneously? Yes, they can occur simultaneously at the same time. They can happen. That, let's suppose weathering is happening and the materials, they are carried away by the rivers, etc. So it can happen. Pranay, can we say Himalayas as an example? For permafrost, some portions of the Himalayas at a very great altitude. Ganesh, why? subsoil is not melting because the average temperature even during the summer is not so very high that the subsoil, please understand, for the subsoil to melt, you need more heat to be released from the lower regions, but that much amount of heat is not released because it is still colder condition, right? Or rather, heat to be released, you have heat to be gained from the lower regions, but that is not happening. Higher latitude, higher latitude refers to the regions closer to the poles. Lower latitude means 0 degree, 10 degree, 20 degree. These are lower latitudes in terms of number also. So the region around equatorial areas, etc., they are referred to as lower latitudes. When you talk about the polar regions, then we are talking about 70 degree, 60 degree north, 65 degree, 75 degree, 80 degree north. These are higher latitudes in the sense very close to the poles. Higher altitude means greater height. Altitude refers to height. And creep, Priya, is when you have very slow movement. In the case when the slope is very, very gentle, in that, if water availability is also less, but you have lot of materials which can move slowly. So in that case, there is a kind of a slow movement which is initiated, and that is creep. The movement can be as slow as maybe 1 centimeter to 2 centimeter per month. Okay. Yes, Prana, that is correct. Himanshu, angle of slope is more than in the case of creep. Yes, in the case of solifluction, the angle of slope is generally more. At which places we observe solifluction? So in the region around Greenland, in the region to the northern portion of Canada, in the region around the Scandinavian nations, that is Norway, Sweden, Finland, in those areas, then the northern, in the Kola Peninsula, northern portion of Russia, in those areas, you will observe solifluction. Okay, is that understood? Any doubts that we have? How are the areas in Darjeeling or other tea cultivating areas is formed? Is it natural formation or man-made? We see tea plant in slanting height. That is obviously the slope would be there naturally. These are basically the hills and the mountains on which it is planted. Tea tea has a specific requirement where it will only grow in the sloping areas. So that is why it is on those areas where tea is favorably grown. For example, even the Nilgiris in certain areas in southern part of the country, there also tea is grown across the sloping areas. So if you are asking whether the mountains are man-made, no. But if you are asking whether the cultivation on those hill slopes and mountain slopes, that is carried artificially, yes, that is artificial. Okay, understood? Okay. How to describe solifluction in one line? Why do you need to describe solifluction in one line? Take 2 lines, my dear friend. Nobody is going to ask you describe solifluction in one line. In case you have to describe, have an elongated one-line sentence that it is a kind of a slow mass movement initiated in the regions of permafrost where the topsoil loses the connection with the subsoil region and in the presence of meltwater indicates a movement. That is what is solifluction. Is that understood? Shilpa, creep is inside soil layer due to water. Creep basically also involves the movement of topsoil, my dear friend. It is not only the subsoil which will move in the case of creep, in the topsoil will also indicate a kind of a movement. Next time when you visit any gentle sloping areas, for example, those of you living in the regions of Maharashtra, some portions of southern Madhya Pradesh, Karnataka, Telangana, Chhattisgarh, Odisha, uh, Andhra Pradesh, Kerala. Now, in the southern part, Tamil Nadu, in all these areas, you will find this very frequently. You will find the slopes in the northern plains, the land is flatter. But in the southern part, in the central and the southern part, you will always find in some or the other areas, there will be slight slope which is there. Not a significant slope that Akshay is associating with the tea gardens, but a slight slope. So you will find that people will grow crops there. They will have their farmlands also there. Now, in that case, you will observe sometimes the boundary wall that starts tilting, the boundary fences that start tilting. That is the creep in action. Okay. Now, after this, we come to the process of gradation, which involves erosion, transportation, and deposition. The entire process taken together is what is referred to as gradation. Gradation is what? Gradation is a kind of a leveling exercise. Okay, it is something which levels the land. Yesterday also we talked about the fact that all the endogenic forces, which are also regarded together as tectonic forces, all those tectonic forces, they can give rise to a certain land characteristic. They can create a fold, they can lead to sudden upliftment of a certain portion of a land, they can lead to the subsidence of a land. But the exogenic forces, they are levelers, they will level everything. So let's suppose you have, and we have taken the case of the Aravallis themselves. Aravallis at one point of time were the mightiest and the quite highest mount amongst the highest mountains across the planet Earth. You had snow-covered peaks and glaciers. What you see in the Himalayas today, imagine the Aravallis would have been like that some point of time in the history, maybe a billion years back or somewhat like that. But then the Aravallis over a period of time, the height of that has been reduced. The height of that has been taken away. Why? Because as the winds they move, as the glaciers they move, they will slowly and steadily erode the materials. The winds will carry some materials along with them, right? Maybe they will deposit them somewhere else. The glaciers will carry some materials, they will deposit them somewhere else. So all of them eventually will lead to the reduction in height. Eventually, all of them, the aim is to create a kind of a level. So that is why that is what is gradation. You basically bring them all to the same grade. So that involves the process of erosion, what is referred to as degradation of an area, transportation of the eroded materials, as well as aggradation, that is the depositional feature or the process of deposition which is carried out thereby. So continuous leveling process which involves three simultaneous activities, that is degradation or erosion, which is the slow process of removal of materials from any particular original region. So let's suppose here if you have a rocky surface, if let's suppose a river flows from here, the river very slowly and steadily will pluck out the materials of these rocky surfaces, that is erosion. Then the river will be transporting it over some distance, that is the process of transportation. Eventually, the river might deposit it somewhere before meeting the sea, and that is deposition or aggradation. So, all these taken together, that is what is referred to as gradation. All of them considered together, that is what is referred to as gradation. Okay. Now, when we talk about this process of gradation that involves erosion, transportation of materials, and deposition of materials somewhere else, they can be carried out by the river water, which indicates the running water. They can be carried out by the glaciers as well. They can be carried out by the winds, by the sea waves, what many of you were talking about, the sea erosion, coastal erosion. They can carry it out. And even in certain cases, the underground water can erode certain materials. Chemical erosion is what they carry out. And they will transport the materials, create structures such as caves, very large network of underground caves, etc. They get created in the process. So those are basically your agents of gradation or the agents of nature which carry out that process of gradation. Okay, so in all of these agents, you will observe they will remove some materials from the original place, they will carry it over for some distance, and then they will deposit it. Okay. Now, we'll take a look at the various landforms which get created due to the different processes of gradation, the different types of landforms created. So, first of all, we'll take a look at the landforms created due to the river action or the movement of the rivers. What are the various landforms which get created? Before that, if you need a break, please let me know. Or should we continue? Can we continue up till 1? Please let me know. Okay, fair enough. So we take a break, and majority of you are talking about a break. So let's take a break. I want you guys fresh when we talk about this topic. So 10 minutes should do. Take a 10 minutes break, and we'll be back after 10 minutes. Okay. A confirmation about the audio, please, guys. If the audio is clear and available, kindly confirm. Thank you. So now we come to the portion where, first of all, we'll do one thing. When we talk about all these gradations, so with the help of this, we will be taking a look at the landforms which have been created or which are created by the river action, landforms which are created due to glacial action, etc. And that is how slowly and steadily we'll take a look at the type of landforms created due to erosion, the various different types of landforms created due to deposition. Those are the things that we are going to analyze as we move ahead. Now, before that, we talk about the stages of river movement. So, when a river is in action, when a river moves, generally you will observe that the river originates from a high altitude area, from a greater height. Okay, it comes hurtling down the slope with a great velocity, with a great speed, and then after that it reaches a plain kind of a region where the speed reduces, where it moves with a gentle speed, and then eventually it empties itself into the sea or the ocean or a larger water body thereabout. So that is the basic process of a river movement. Now it is in this process that the river ends up eroding materials as well, depositing materials as well in the process. Now, when we talk about the stages of river movement based upon their individual characteristics, based upon their individual or at each of these areas, that is, whether it is coming down the mountain or the hills, or when it is flowing across the plain area, or whether it is meeting the sea, each of them will have their own individual properties. Accordingly, the river movement is divided into three different stages, that is, the youthful stage, mature stage, and the old stage. Okay. Shrimant, what is the exact time of class? I think you had asked this question yesterday as well. So for the weekends, we have the class timings from 12 to 8 on Saturday, and on Sunday, we have the class timings from 10 to 8. Okay, Shrimant. So a wake up call. So here, basically, in all the cases, you will find, in most of the cases at least, that the rivers will originate from a greater height. So that is the stage which is also regarded as the youthful stage of the river. So that is the youthful stage, which is also referred to as the upper course of the river. Okay, youthful stage of the river. Then you have in the youthful stage, here you can think about it, that we are talking about a region where the slope is significant, and in that slope, excuse me, across that slope, you will observe that the river starts moving down with a particular speed. Okay. Now, as the river comes down the slope, its energy will be high, its velocity will be very, very high, always. Now, its erosion power or its eroding power will be also very high, in the sense that it will be hitting these materials, it will be hitting these rocks with such a great intensity and velocity that some of the particles of these rocks, some of the portions here, they will be carried by the river. The river can carry them to a far away distance by each one of them. Okay. So when the speed is very high, its ability to carry materials also is high. Right. When the speed of the river is very high, it will be able to carry lot of materials to a lot farther distance. When the speed reduces, then it won't be able to carry so many materials. You would have observed this, not in the case of the river, if at least you would have observed it in the wind. That is during the late summer season, before the monsoonal rainfall comes, when you have very high velocity winds blowing, you would have observed that in case that there is very less wind or less speed of wind moving, some dust particles are lifted. But during the case of a thunderstorm, when you have very high velocity wind moving, now not only are the dust particles carried, various different other goods, pieces, everything is carried by the wind, isn't it? Newspaper pieces, plastics, smaller light thermocol pieces, everything is carried. If the wind becomes very strong, sometimes you would have seen, if not in real life, at least in the videos you would have seen, that it can take away few of the houses as well, few of the vehicles as well, everything the wind will carry. So what does that tell us? That tells us basically that carrying capacity for all the agents of nature, carrying capacity is directly proportional to speed. So that means for any agent of nature, if the speed is high, it will be able to carry more materials. When the speed is less, its ability to carry materials decreases. So what will happen to the materials that it is already bringing along? It will start deposition. So when the speed is high, more materials can be carried. Okay. So when the speed is less, less materials will be carried. So what is going to happen to all the other materials that it was carrying from before? It will start depositing it. So with lower speed is associated with less materials being carried. And that means deposition will happen. Okay. That is the aspect, or that is the fundamental which goes true for all the various agents of nature, something that you can associate with your real life example as well. So in the youthful stage, speed is very high. Why? Because it is coming down the slope. So when the speed is very high, its ability to carry materials will also be very high. So that means the erosion will also be very high. So here, rate of erosion will be very high. Erosion is very high. See, guys, everything is something that you can deduce by logic. I don't want any of the candidates sitting here to unnecessarily start learning things. When you start rote learning things, that is when you create a scope for not only mistakes, errors, but also you will forget it as well. And that creates a lack of confidence. I'm not sure how you have carried out your fundamental of studies in your school days, in your graduation days. That is something that I'm not going to delve deeper into. But generally, when you try to understand things, when you start deducing things by logic, you will have to know very few things. Very few things are there that you will have to keep in mind, and that is only the basics. From those basics, you can have the derivation. For example, even this basic is something which is going to have enough amount of material for characterizing the entire process of the river movement. Okay. Deposition is also may high. No, deposition is not going to be high when the speed is high. How is it the case that when the movement is high, when the speed of movement of any material is high, where will it deposit? It will try to carry as many materials as it can. When the speed suddenly reduces, that is when it will deposit immediately on the sides, everywhere it will start depositing. Now the rate of erosion is also very high. Now, when we say erosion, when a river is coming down the mountainous areas, now again, those of you living in the mountainous region, or those of you basically uh, having went to the mountainous areas for trekking adventure purposes, or even if nothing, seen a video on YouTube, etc., you would have observed that in the mountains, none of the river is very wide. That is not the case. Rivers in the mountains, they are narrow. Right. They are not very wide. It is after they come down the slope of the mountains, that is when they start becoming wider. But within the mountains, they are narrow, but they are deep. So when they are eroding materials, they are going to erode materials vertically. right? Why? Because the river action, if you can imagine it, the river action is coming like this. The river is coming down the slope like this. If let's suppose this is the slope, river is continuously flowing like this, it will dig it up. It will create a kind of a vertical depression of sorts. So here, vertical down cutting or the vertical erosion is quite significant. So valleys, gorges, etc. That is something you will find as a common factor here. So vertical erosion is prominent. Deposition is very less actually. In the case of the mountainous areas, the only place where the river will deposit is immediately as it hits the base. There itself, the river will deposit something. That's it. Okay. Otherwise, in the youthful stage, deposition is minimal. Deposition is minimal. Then comes, so think about it. Always, I tell the candidates also that in case you are finding difficulty in relating to it or trying to remember it, the various stages of the river, always have an analogy to the human life. In the youthful stage, when you are young, right, in the sense that I'm not talking about that youthfulness is till when you die, it is about mindset. I'm not talking about that kind of young. I'm talking about when you are up till your teens, for example, 19, 20, 18, in that level. So I'm assuming that people, all of us here, we have started maturing in our 20s. I'm assuming that in the rate of maturity increases thereafter, and that is purely subjective, by the way. But if you recall, and in case you are in your teens, you will basically associate with it, the energy level is very high, right? Many of the times a kind of meaningless energy is there, but energy is there. You want to do something, you move from one place to another continuously, the energy level is so very high, right? There is no moment where you want to take rest. You want to do everything at the same time. You basically want to bang your head in the wall. You want to do something out there, right? And you are very restless. There is no patience at all. I want this today, I want it immediately, otherwise my life is gone. So that kind of energy that you have, that is associated with youthfulness. You will never find an individual who is maybe 25 or 30 or 35 or 40-year old having that kind of a wasteful energy of sorts. So that is associated with youthfulness. Something very, very similar that you find in the youthful stage of the river action as well. Then comes the mature stage of the river. This is the middle course or the mature stage. Why deposition is minimal at the youthful stage? Because the carrying capacity of materials is directly proportional to speed. When the speed is very high, there where the materials are eroded. So where will it deposit the materials? The river, when it is moving at a very high speed, where will it deposit the materials? It doesn't have a place to deposit the materials. So erosion will be very high. So that is why carrying capacity is proportional. Carrying capacity is what we are talking about. We are not talking about the carrying capacity that more water will be there if the speed is very high. If we talk about this, carrying capacity is the amount of sediments, eroded materials, etc., that it can carry. So, again, I will give you the analogy of the same wind example. When the wind is blowing with a very high speed, is it depositing materials or is it carrying materials with it? So, it will be carrying materials with it. So, that is when the speed is high, it is the force of erosion which is prominent rather than the force of deposition. So that is the prominent feature that you will observe. Is that understood? Anyone having any doubt in the portion of carrying capacity or the process of deposition? Do erosion takes place in waterfalls also? Yes, they do. What is the doubt, Madhuri, that you have? Please ask the question. Please ask the specific question, Madhuri, and then we will solve that question and we'll move ahead. Because of network issue, I can't understand. What is the doubt? What is the exact doubt that you are unable to understand? I hope you are not expecting me to repeat the entire thing process again. The gradation topic is form of formation of landform. Yes. Sediments and eroded materials are same. Yes, it is a process of erosion which creates the those particular sediments which are carried over a larger distance. Vertical erosion. What is vertical erosion? Okay, observe this. You are able to observe this. This is the river which is moving at the base. Now, how do you think the river is moving here? Do you think that the mountains basically have created that kind of a gap so that the river can move? No. At one point of time, the river movement would have been somewhere here, and it has eroded it vertically. That is what is vertical erosion. So basically, when a river comes down the slope of the mountains, the river will try to deepen the channel, it will try to erode more. So that is what is vertical erosion. So when we talk about vertical erosion, if let's suppose on a region the river is moving like this, it will carry out, if let's suppose here is where you have the river movement, if here is where you have the river movement, it will start deepening it, it will continue to deepen it, right? So that is vertical erosion. Sometimes the river becomes broader, it becomes wider, that is horizontal erosion. Where it becomes wider, that is horizontal erosion. Where it gets deeper, that is vertical erosion. Okay, is that understood? About the process of vertical erosion. Is that process understood? And vertical erosion will happen when the speed is high, yes. And sediments and eroded materials, I have answered that. Stages of river movement. We are not done with the stages of river movement. We are still in the process of that. Pavitra, so I hope you have understood the process of vertical erosion. And good. Why in specific place only erosion happens? Because wherever the agent of nature will be there, like river, wind, etc., there erosion will happen. It is not the case that, let's suppose there is a sloping region in Andhra Pradesh, but there won't be any erosion in Andhra Pradesh, because erosion, God has said that erosion will happen only in Himalayas. That is not the case. Conducive conditions, wherever they are present, erosion can happen in that region itself. Okay, erosion is not space or time dependent. Erosion is basically dependent on the topography. If let's suppose the river is before meeting the sea, river will not erode, it will deposit. Okay, right. Now, so in the youthful stage is when the river comes down the slope of the mountains. If you want to visualize it, think about it in a kind of a rough image, if I can. So let's suppose you have a kind of a mountainous area. Okay, let's suppose. And from these mountains, let's assume that the river is originating. From these mountain slopes, let's assume that the river is originating. Now, as the river is coming down the mountain slopes, due to gravity, its speed will be high or low? It will be very high, always. As the water flows from a higher elevation to a lower elevation, its speed is always going to be very high. So when with a high speed water hits a rock, let's suppose water is coming down with a very high speed and it hits a rock, what will happen to the rock? It will start breaking slowly and steadily. It will start breaking, isn't it? Small fragments, and that will be carried by the river. That is erosion. So here, basically, The river, as it comes down the slope, it will have very high speed, it will erode. But as soon as it enters the plain area, it will become wider, because now it can become wider. In the mountains, it doesn't have the scope to become very wide. In the mountain, it is flowing through a certain channel, it is flowing through a certain path. But as soon as it confronts the plain area, it can become substantially wider. And that is where the river, basically, when it comes into the plain area, you will observe that it becomes substantially wider, right? The flow, the speed decreases, and eventually, after moving a considerable amount of distance, maybe it will meet the sea. Okay. Now, in that case, in the initial stages, always this is the youthful stage. This is the youthful stage. That is the stage where you will observe materials to be eroded. Okay. Materials to be eroded is what you will find in that case. Right? Now, here, in the youthful stage, as it is coming down, it will have very high speed. It will erode materials, but it won't be eroding materials horizontally. It will be hitting the materials directly due to the force of gravity. And that is why the river will get deeper and deeper. It will get much deeper. And because the speed is very high, all the energy will be consumed in eroding the materials. There will be almost negligible deposition. That is the youthful stage, high of energy. Then comes the second stage, which is also referred to as the mature stage. That is the mature stage of the river. When we talk about the mature stage, the slope would have reduced quite considerably. For example, when you take the case of river Ganga, when you take the case of river Brahmaputra, any of them, immediately after they come down the mountains, when they come to the plains, it is not as if the plain region doesn't have a slope. It still has some amount of slope. For example, in the case of river Ganga, from the region of Haridwar to the region of Bay of Bengal, there is still some kind of a slope towards the region of Bay of Bengal. That is why the river moves in that direction. Otherwise, the river would have moved in different direction. So the slope is still there, it is less. So that means the speed is still there, but it is less. So there will be erosion, but now, rather than vertical, you'll find the river to become wider and wider and wider. That is why in the plain areas, consider any river for that matter, Godavari, Krishna, Kaveri, Ganga, Brahmaputra, Indus, any of the river. When they come to the plain areas, they become much wider. Okay, so that is because there is a horizontal broadening of it. There will be deposition also, which shall be carried out simultaneously because the speed has slowed down. Okay, so here slope is less as compared to the earlier situation, to youthful stage. Okay, so the slope is less. Then after that, you would basically find that widening, that is horizontal erosion of the river takes place. Then after that, depositions do happen with the reduction in speed. Okay, depositions do happen when the speed of flow in a way reduces. That is the middle course or the mature stage of the river action. And then you have the lower course, that is eventually before meeting the sea. That is also what is referred to as the old stage, right? Again, I would tell you that have a similarity with the life cycle of the humans as well. In the mature stage, you have a measured energy. You have energy, but it is absolutely measured. You would apply your energy only when it is required. Not randomly, you will start banging your head here and there. So, similarly, when the river comes into the mature stage, it still has got some energy, it still has got some speed, but it is measured. It will have a definite path in which it will flow, it will navigate. Then in the old stage, just like in the old stage of the humans, the energy level is absolutely low, right? You barely move through. So same is the case with the rivers, that here you will observe slope is almost absent. Slope is negligible. As a result of that, speed is very less. When the speed is very less, that means no erosion at all. Only deposition will happen. No erosion, complete depositional processes. Process dominate. Okay. So these are the various different stages that you will observe. The youthful stage, the mature stage, and the old stage. So youthful stage is where the river, being very young, has got high amount of energy, will be able to erode much more materials. Mature stage is when it will be slightly mature in the sense that there will be still some slope, but largely materials will be transported, there will be widening of the river channel, and it will start depositing materials in this stage itself. In the older stage, the speed would have reduced so much that only depositions, they do take place. These are the general stages of the river movement, where the youthful stage is also referred to as the upper course, mature stage is referred to as the middle course, and the old stage is also referred to as the lower course of the river movement. Okay. Now, then we take a look at the landforms developed by the river movement. What are the various landforms created when the river movement is in existence? So here you have erosional as well as depositional landforms created by the river movement. Amongst the erosional landforms, you will find that majority of them, they are created in the youthful stage itself, because that is when the erosional power is very high. So valleys, gorges, potholes, plunge pools, all of them, they are created in the youthful stage. Youthful stage. Now, incised meanders and river terraces, they are created in mature stage, but they are not created naturally in every river. This is created when there is a combined action of endogenic and exogenic forces. These are very unique landforms. We have studied that, as per the study, we have seen that endogenic forces or epirogenic forces are what? Basically where the land gets uplifted. Sometimes the endogenic forces, we have seen, they can lead to the upliftment of the land, they can lead to the subsidence of the land as well, right? We are comfortable with that fact, that if you have any land, let's suppose any land here, if the endogenic, now if let's suppose there is a river which is moving in that area, let's assume, okay, there's a river which is moving in this area. Now, it can also happen that due to endogenic forces, land area in this region can get uplifted. Here, land area can get uplifted due to the endogenic forces. Now, how will the river respond? The river will continue its own path. Whichever portion is getting uplifted, the river, if the upliftment is very fast, that is in the sense that if the upliftment is happening at few meters on an annual basis, that means very fast upliftment, then the river will have to change its direction, water will get accumulated. But generally the upliftment which happens is very slow, maybe 1 millimeter 1 year, maybe 1 millimeter in 10 years. That might be the rate of upliftment. So in 1 millimeter rise of land in 10 years, if it is happening, then the river will continue its flow. Any upliftment happening on the river channel, river will immediately erode it, right? So that is basically the case of what leads to the formation of incised meanders and the river terraces. So these are the only two erosional features that you will observe that is present in the mature stage. Okay, and Akshay, I think I have answered your question that erosion takes place in waterfalls also. Yes, erosion does take place in waterfall. That is what leads to the creation of plunge pools. Okay. And Srimant, you had a question that I miss out the early 1 to 2 hours due to the time unknowingly. So don't worry, my dear friend. Even from this point onwards, if you try to follow it up, it is largely driven by logic. I don't think you should find any difficulty in these. Okay. Then we come to the depositional features. Depositional features are when you have a rate of deposition. When you have deposition which is carried out by the river, they also create unique kind of landforms. We'll take a look at these landforms. Now, where is it that the deposition happens? Generally in the mature stage, late mature stage, or the old stage. That is when deposition happens. So majority of the depositional features that you will find it in late mature stage or the old stage. For example, here, all these that you see, this will be in late mature stage. Alluvial fans you will find in youthful stage. Okay. Deltas you will find in old stage. Even braided channels you will find in older stage. Okay. So all these landforms, they get created in different stage of the river movement, depending upon what is the speed. If the speed is high, there will be erosion. If the speed is slow, there will be significant amount of deposition which will be carried out. One by one, let us make ourselves familiar with each of these landforms. Let us try to visualize how they get created so that we are able to understand the process as well. So first of all, we'll take a look at the erosional landforms. Then we'll come to the depositional landforms. Amongst the erosional landforms, the youthful stage erosional. So we talk about the valleys and gorges first. What are they? So valleys, basically what you see here, right? This is a kind of a valley. And what you observe here in this first image, that is a gorge. So what is the difference between them? This is a gorge. So simple visual analysis will tell you that the gorges, they have steep walls, they have very steep side walls, they are deep. Whereas the valleys, they basically, the bottom is also broader. Whereas in the gorges, the bottom is very narrow. In the valleys, the bottom is broader and the walls are also in a way gentle sloping in the case of the valleys, isn't it? So that is the basic difference that you will observe here. Now, valleys are depressed areas of land scoured and washed out by the conspiring forces of gravity, water, and ice in certain cases. They can take a shape of U or a V. Whereas gorges, they are deep, narrow valley with very steep side walls, usually formed by a river or stream cutting through a hard rock. Both of them are created due to vertical erosion. Both of them, they are created due to vertical erosion. Are created due to vertical erosion. Okay, so here you will observe when we talk about a gorge, largely the gorge will have very steep walls. Largely, it is resembling a kind of an I shaped valley. You would have studied this, I'm sure, even though you might feign ignorance that I have never studied this, but it is there in the class 7th and 8th syllabus. So, in your school days, you might have studied this. And in case you don't recall any of it, that also tells a lot, not only about our education system but how we have studied that. Okay, so basically, does anybody remember this, or getting confronted with these terms in your school days, or is it something that it is from the past life that we have completely forgotten? From this question, from this topic, what kind of questions may be asked? Let us finish the topic there, first, and then we'll come to it. Familiar with these concepts? Can't recall. Hmm. So, geography as a subject in class 6th, 7th, 8th, 9th, I will be very happy to have an interaction with all of you one day. That what is it that you would have studied in the school days, and what is it that you recall from your school days, right? Because I, being older than you guys, if I am able to recall the what was there in the school days, so either something has gone horribly wrong with our education system, or otherwise we have done the schooling. Okay, how many of you basically have never given the exam till appearing for class 10th or 11th? Because I understand the no detention case was also there. It was only a 10 marks paper, was it? Oh my god. Okay. No, then if I am expecting you guys to remember it, then it is my fault. If the entire portion of geography was for 10 marks and 3 marks for economy, 10 marks for geography, 3 marks for economy, and how much for history? That is why we have such kind of a proficiency, is it? Okay. And all the faculties here, we are scratching our heads that this is something that would have been taught in the school. Yeah, okay. Fair enough. Nonetheless, let's revisit this again then. So when we talk about gorges, so gorges basically here, yes, Ayman, all these landforms are identified by the physical features only, the physical properties that they have. So, gorges are in a way very steep sided, narrow bottomed valley structures. Very, very steep sided, narrow bottomed valley structures which are present. Okay, that is what we refer to as gorges in general. So, here, this is where the river will flow. You have to understand that this region would have come into place due to vertical down cutting. It would not always have been the same. It would, at one point of time, it would have been a river moving through this area, but the river would have cut that place vertically, eroded that vertically, and now you have the creation of these narrow gorges. Okay, so that is what you refer to as a gorge. It is not a gorge, it is not a jorge, it is a gorge. Okay, so the gorges, they have steep walls, narrow bottom. Valleys, on the other hand, they are broader, they have a broader bottom. That is why I want you guys, all those proficient people from school, I want you guys to have some difference in your approach here. Rather than ratifying and rote learning the definition in one sentence, etc., observe the images, guys. Please observe the images here. In the case of the image here of the valley, you will observe that the river, observe the river movement here. River movement is something which is happening here. Maybe in some days the river will move from here, maybe somewhere here. But you have a broader bottom. The base is broader, right? The slope is gentle in the case of a valley. A gorge over a period of time can get converted into a valley. That is something which is absolutely possible, that over a period of time, a gorge can get converted into a valley. Gorges in Himalayas, for example, they have a significant amount of depth. For example, the river Indus. when it cuts through the Himalayan mountain range. It creates a gorge from the nearest side. That gorge has got a depth of 5 kilometers. So think about it, that the gorge basically here from the side of the mountains can have a depth of 5 kilometers and more. So that tells you that the gorges can be created due to significant vertical down cutting. And by the way, another portion which is not there, or which is not going to be asked in your general studies portion, but I think you should have that concept in your mind as you approach this topic. Any erosion, any amount of erosion which is carried out, it will be carried out up till the depth of the sea level, right? It won't be carried out beyond that particular depth. Generally, that is included in the cycle of degradation or the cycle of erosion. So basically, any kind of erosion, the deepest that the gorges go, they will never go below the sea level, the mean sea level, which is considered to be a reference height across the world. I hope we are aware of that, that when we say Mount Everest is 8.8 kilometers higher than the mean sea level, so mean sea level is considered to be the average reference height. So any of the process of erosion, whether carried out by the wind, whether carried out by the river, glacier, anyone, it won't go beyond the depth of the sea level, always associated up till the sea level. Okay, keep that somewhere in the back of your mind. Now, as I was telling you, the gorges can very well easily be converted into a kind of a valley. All it requires is a host of different processes of weathering as well as mass movement. For example, here, let's assume due to vertical erosion, you have creation of a gorge. The vertical erosion here has created a kind of a gorge here, right? Now, in this case, here, it is almost vertical, created due to vertical erosion. Now, over a period of time, weathering will happen in all these surrounding areas. The rocks that you see, they will get weathered here because already plants, grasses, etc., they start growing. So they will get weathered. Now, when the weathering happens, these rocks, they will get weaker, right? Over a period of time, mass wasting, because now they have disintegrated into smaller particles. These are free to move. So then, due to landslides, etc., they will basically simply start sliding down. Mass movement will occur. And then eventually you have creation of a wider valley bottom. Eventually, even this valley can get broader and broader as this process will continue. So this valley will also keep on getting broader and wider. Right. So the process of erosion, weathering, mass wasting, here they can act simultaneously. And then a gorge can have the base also broadened, the slope also broadened, and the entire region can change its structure from a gorge region to a kind of a valley. It is not always going to be the case, but in majority of the cases, the valleys that you see today, in many of the cases, they were gorges of the past. And the gorges of the present, in many of the cases, they can end up creating valleys of the future. Okay? Now, after this, we come to some other features, erosional features that are there. That is, we come to the portion of potholes. Right? Now, potholes are something that you see here. Potholes are something that are associated with the river action, generally observed in the youthful stage of the river. I will flip back from the screen, otherwise, immediately everybody will concentrate on the definition itself. I don't want you to look at the definition now. I just want you to understand what the potholes they do look like. Potholes look like this. Now, here, the sad part is that we find these kind of potholes. For this, we don't need to go to the river. We can find it in the river, in the roads itself. When we venture out in our cities, in our normal roads also, we find these potholes much bigger than this. But how do these potholes get created? These potholes, they get created in the youthful stage when the river bed, in the youthful stage, there is a slope. Now, in the riverbed, when you have large stones, etc., hitting the riverbed, the riverbed breaks and there is creation of small hole-like portion. Now, the next stone will automatically be attracted there because of the fluid dynamics. Water will push that larger stone there itself. So the holes, they start getting broader. That is how the potholes they get created. Let us understand that in slightly greater detail. When we talk about the potholes, they are circular depressions formed because of stream erosion aided by the abrasion, the breaking and the rubbing of the rock fragments. Once a small and shallow depression is created by hitting of the rocks, pebbles and boulders they get collected in the depression, they get rotated as the water moves above them, and that widens the potholes. Understand this process with the help of a schematic image. So let's assume here, when you have, let's suppose this being the riverbed. I think the slope is too high here. So let's have a slightly gentler slope of the riverbed. On top of that, you have the river action, the river which is moving on top of that. Now, you would have observed from your own experience as well that when the speed of the river is high, it is able to sometimes carry large stones, large boulders as well. Boulders are basically fragments of very large rocky areas. So it is able to carry them. But how are they carried over? So they roll. They basically get to be rolled over. So let's suppose you have few of the boulders, larger rock pieces, etc., which is being dragged by the river. So the movement will be somewhat like this. It will hit the base here, right? Weaken the base. Then again, the water will carry it. Again, it will hit the base because there is a slope associated. So it will be carried over. Again, it will be hitting the base here, right? So the boulder or the rock will be rolled over like this. Now let's suppose in all the places that this rock has basically hit the riverbed, there is some amount of slight depression or some weakness which is created. Next time again, another rocky piece comes. Here, if it hits this portion again. So that repeated hitting of that riverbed by the rocks, boulders, pebbles, gravel, etc. in the same region, that creates these indentions that we refer to as potholes. So that is how these potholes they get created in the youthful stage in the river bed. Okay. Then we have what we refer to as the plunge pools. Now plunge pools they are created at the base of the waterfall. Now there again you do have the role played by the high velocity of water. So basically when we talk about plunge pools, so let's suppose we consider a region of a waterfall. Now, generally in the region of a waterfall, you will observe a landform somewhat like this, isn't it? Now, let's assume that water is moving over this. There is river water which is coming here. And generally, when the water comes, it will hit it like this. And the water will be moving forward, right? The river will basically hit the base, the waterfall will be somewhat like this. Now, that repeated falling of water with a great height, that is also forceful, that also carries a force. Now, continuous falling of water in this region, they will end up creating a kind of a depression in the area immediately at the base of the waterfall. The rocks will be eroded at the base, and at the base of the waterfall, it will get slightly deeper, right? Now, this is carried out purely because of the process of erosion due to the impact of the movement of water. As the water is falling here, the impact created by this, that will create this kind of a depression. This depression which is formed, that is what is referred to as plunge pool. That is why now every year, many people, hundreds of people across the world, they lose their lives in these plunge pools. It is always advisable, that is why, that never go to the base of the waterfall, right? In our country also many people lose their lives because of these plunge pools. Unless and until you know the exact depth of the water in this region, you should never venture out, because the problem what happens is that when you are an individual standing in this particular region, let's suppose, the water will come up till your knee length, right? So you will be very confident that, okay, water is up till my knee length. So even if the water level is higher, it will come to my waist. Not an issue at all. But suddenly, when you enter at the region of the base of the waterfall, due to the plunge pool, it can get very deep, right? In many of the areas, the plunge pool is so deep that from knee length, immediately it will come above up till your head high. And then once you basically somehow you basically get trapped in the plunge pool, it is very difficult to come up because water is coming down and pressing you down with a substantial amount of force. So again, to come up from that, that becomes very distinctly difficult. So that is why always advisable that never go immediately at the bottom of the waterfalls, right? Because that creates a lot of issue, that causes a lot of casualties on an annual basis, on a daily basis across the world, across various waterfalls. But this again, waterfall mostly observed in the youthful stage. So this landform again is something that you will observe in the youthful stage. So they are large, deep potholes commonly found at the foot of the waterfall, formed because of the sheer impact of water, rotation of boulders. They create that erosion, and that has created that kind of a depression area at the base of the waterfall. Okay. Now, Akash, how gorge would have been created, river direction would be where? Okay, fair enough. I'll take you back to this particular image, Akash. Observe here, the river is moving down the slope in this case, right? Now, as it is coming down the slope, it is going to dig the slope further, it is going to dig it furthermore. So it can happen that in these sloping areas themselves, you can have the existence of a gorge. That is why gorges generally are in existence between the mountains. It is between the mountainous areas where you will find these very deep gorges in existence, and it is created because of vertical down cutting. Here also the river will cut it vertically. So after few years, you won't be able to visualize or see the river like this. It will be something which will be at the base of a gorge moving through this area. Okay, I hope that helps, Akash. In case it does not, please let me know. We will further try to simplify it. Then we come to the portion of incised meanders and river terraces. These get created in the mature stage of the river action. And these can get created only when you have the sudden upliftment of the landmass taking place due to endogenic forces. Okay, so here this gets created basically because of uplift of the land, and that has led to renewed amount of erosion. So that uplift of the land has happened because of the endogenic force. Endogenic force. We have seen that endogenic forces, they can uplift the land, they can lead to subsidence of the land as well. Okay, so this endogenic force, that creates an upliftment of the land, and that can end up forming these incised meanders. Incised, what is the meaning of incised? Are we aware of the meaning of incised? Anyone? No. Okay. Yes, something which is cut in, something which has been cut in and put there. So what is the meaning of meander? Meander is a kind of a wavy path, which is not a straight line, but a kind of a wavy path which is there. That is meander. So many of the times in the youthful stage of the river, again, I will draw you back to the same image that we had seen earlier. In the youthful stage of the river, or not in the youthful stage, in the mature, late mature stage, the river ends up forming a kind of a meander. When the slope starts reducing, the river is unable to flow in a straight path, and that is when you will observe the river to form a kind of a meander. Okay, so let's suppose the river has formed a kind of a meander like this. Okay, now that is where the river has been flowing. Now, due to endogenic forces, this particular landmass in this area and this particular landmass in this area, let's assume that this landmass has been experiencing a rise, a vertical rise. Let's assume that this landmass has been experiencing a kind of a vertical rise. Now that rise, if it is very fast, happening very quickly, the river will have to change the direction or the river water will accumulate, because then the river cannot flow. But let's suppose the rate of rise or the upliftment is very, very slow. Then what happens? Very slow means maybe 1 centimeter in 1 decade, 1 millimeter 1 year, something like that. Now, in that case, land here will get uplifted, land here will get uplifted, land here will get uplifted, land here will get uplifted. What about the river bed? There also it will get uplifted. But uplifted by how much? 1 millimeter, isn't it? So if I have to chart a path of the river bed, so can I not say that the river bed will indicate a kind of a plane feature, but suddenly in one portion it will be raised by 1 millimeter, and then again that height will be neutralized. That will be the rise on the riverbed. Now the river is moving with full force over this area. The river is moving with full velocity. So what will the river do to that upliftment of 1 millimeter which has happened? The river will immediately erode that obstacle, right? So at the riverbed, river continues to erode any amount of upliftment which is happening, isn't it? So at the riverbed, the river erodes any kind of upliftment which happens, right? Whereas in the surrounding, the land is continuously getting pushed up. There is nothing to erode the land on the surrounding of the river, isn't it? So if this was the earlier cross section, you would observe that the river is continuing to flow at the same height because it is eroding everything, any upliftment which is happening across the riverbed. But all around it, the uplift is continuous. There's nothing to erode it. So then, eventually, the landform which gets created, it is as if a meander has been cut through this particular land, right? That is why it is referred to as a kind of an incised meander. It is as if the meander has been cut it and carved into this particular land portion. So how does it look? It appears something like this. So here, if you take a look at it, observe here. Now, you see that, I don't know, I don't know if any of you have referred to it, but any of the foreign universities, the if you talk about any of the good universities outside, the geography books that they have, you will be very intrigued to find those geography books. They are very, very costly, by the way. Yeah, any one book can cost you around 5,000 to 10,000 to 15 to 20,000 rupees easily. Now, you know the methodology by which they emit that information, those books, they will have almost minimal text. They will have only images. And it is the deduction from the images by which one can gain a lot of insight. So that is what I always maintain, that rather than going through a text, if you analyze the images carefully, you can deduce a lot. Let us deduce something from this particular image. First things first. Here, observe the incised meander in this region. This is the river flow, isn't it? This is the river flow. That tells you that the surrounding land has risen up, whereas the river has maintained its original flow. Now, observe something else. What can we gather from here? If you notice this image carefully, and please pay attention for a brief moment. If you notice this image carefully, you will observe that even in this slope, there is a kind of a linear pattern. I want you to observe this carefully. There's a kind of a linear banded pattern of sorts, isn't it? Now, how do you think these patterns have gotten created? And these patterns, what you see this side, it is exactly replicated on the other side as well, in the same structure of the bands. Again, there is a gap. Again, there is a structure of the band. That indicates various different times in which the upliftment would have happened. That indicates that at one point of time, some upliftment would have happened. It would have continued for a few thousand years. Then again, another phase of upliftment would have happened. And that tells you the existence of multiple bands here. Observe here, this band here as well. That means another phase of upliftment, another phase of upliftment, another phase of upliftment. Now, observe here that the walls in this region are vertical almost. Almost vertical. What does that tell you? That tells you that the final upliftment which would have happened would have been a continuous process. That means from this portion, at one point of time, this would have been at the level of the river, right? It would have risen up. But rather than having that periodic upliftment, it would have been a continuous upliftment. That is why the continuous upliftment means a vertical erosion which has happened along the riverbed, while on the sides the region has continuously uplifted. Right? In this structure that you observe here, all this. Now, here you will observe something more unique. You will observe that the height of this is slightly greater than the height of this. What does that tell you? And this is very narrow as well. What does that tell you? That tells you that at one point of time, even this portion would also have had the same height. But weathering and erosion has led to the breakage of those materials, whereas these materials, they are still getting weathered, they are getting narrower, they are getting smaller. Observe here, they are getting smaller. But nonetheless, there is rise. There is this rise. Observe these bands. Indicates various different phases of rise, and this will also help us understand, if we measure this carefully, that for how many years that rise would have continued, for how many thousand years, then for how many thousand years there would have been a pause in that rise, again that rise would have happened. This tells you that the rise has happened multiple times. Okay, and it has created, while the riverbed has managed to erode the bottom, the top has risen up. So this is what is your incised meander. Is that understand? Is that something which is understood? Uh, Priya, then why not the eruption happened here? Which kind of eruption are you talking about? As you shared recently, which eruption are we talking about, Priya? Please emphasize that. This is about erosion, water erosion. This has been eroded. The vertical erosion has happened. What vertical erosion and where vertical erosion? The understand, the river is continuously eroding vertically across its river bed. It is not allowing so this river bed also, when it is getting uplifted, along with the rest of the materials, the river bed also, when it is getting uplifted, the river flow is eroding any upliftment across the river bed. That is why the river is able to maintain its original course. Whereas the remainder portion of the land, there is nothing to erode them. That is why they are getting uplifted. Right? If there would have been a river flowing through here also, it would also have eroded it continuously. Any new upliftment which would have happened, it would have managed to erode that as well. But that is not the case. Okay? Why did the river took curve shape and not straight? and erode the rock. See, the river takes a curvilinear shape or a meandering shape when it is moving through the plain area, when it is moving in a mature stage. That is when these meanders are created. Meanders, how do they look like normally? This is what the meanders look like, generally observed in the plain region. But if the region suddenly gets uplifted, the river will maintain its original flow. But all around it, the land will get uplifted. All around it, as the land gets uplifted, it creates a situation, a scenario somewhat like this. Is that understood? Uh, Karan, why river does not follow the shortest straight path? If the slope would have been there, the river would always have moved straight. But the river does not move straight. Do one thing: the room that you are sitting in, there, if the floor is absolutely flat, then pour some water in the center. You'll find that the water accumulates and the water tries to find out its path. Now it will have a kind of a wavy nature. But then, if there's a distinct slope, maybe in the washroom or any part of your room where the floor has a distinct slope, pour some water, it will flow in a straight line. What does that tell you? That whenever you have a distinct slope, it always flows across a straight line. But whenever the slope is not there, it is plain region, water, in order to find the flow, it follows a kind of a curvilinear path. Can you please brief this again, how this meander is the reason of upliftment of the land? Okay, how many of us we have the conception that the meander is the reason for the upliftment of the land? Anyone? No? Meander can never be a reason for upliftment of land. Upliftment or subsidence of land will happen only because of the endogenic forces. That is something very independent. Now, upliftment or subsidence of land happening somewhere else, that might not impact us at all. But if it is happening across a river, the river will erode it. So that is when you get the creation of the incised meanders. Not sure about it. That is the best answer. Akash, it means at one point of time the river flow and the hilltop were the same. Absolutely. Good. So, Gauri, doesn't that mean that stone or rock at the same place and the river is going downward? No. The river, okay. See, take a look at this image. This is the first image. This is the second image. This is the height at which everything was there initially. But then everything got uplifted. What about the riverbed? Should the riverbed also get uplifted? First of all, are we comfortable with the uplift of land or not? Are we comfortable with the fact that the land can get uplifted and the land can sink? We are comfortable with that, everyone? Please let me know. Any doubts that why the land can rise, etc.? Everyone is comfortable? Clear? Okay. So the land basically can get uplifted. Why? Because of the endogenic forces. That is the forces from the interior. When they act, the land can get uplifted, the land can sink as well. Right? That is the situation. Now, what if we consider this particular, now the other main area where many of you are finding it very difficult to digest is, why is the river not moving in a straight path? So I ask you a counter question: does the river always move in a straight line, or have you ever seen a river moving in a wavy manner? Do you think that the river always moves across a straight line? No, that is never the case. If that would have been the situation, then rather than having the river path drawn randomly, all we, for example, for river Ganga, we could have done one thing: we could have taken a scale or a ruler. We would have joined a straight path from Haridwar to the region of Bay of Bengal, and that would have been the path of Ganga. Why doesn't river Ganga take that path? If ever you have traveled between the various different areas within your state itself, within different cities, if you would have traveled, you would have observed that the rivers, they take a curve. multiple times the river takes a curve. Why do you think that is the case? Have you, any one of us who basically who are unsure about the fact that the river can take a curve? Any of us? No? So we are comfortable with that. So the rivers can take a curve, rivers can bend. Okay. So once that problem is solved, now then, if I take you back here, again, I will give you another image also. Here also river is taking a curve. Here also river is coming from here and then taking a curve. So rivers can bend. Rivers always will bend. Okay, that is a very natural process of the river. Now, in a kind of a pedagogy that many of you will understand, why it has a wavy nature. Again, the same question. That is why it is going to have a wavy nature. Due to the land feature. When the river flows, ideally, if the slope is very distinct, it will always try to flow in a straight path. But then the slope is always not very distinct. So in that case, river forms what are referred to as meanders, which is a kind of a wavy pattern, right? That is what we refer to as a meander. So if I tell you before what is meander, observe here, basically, if the river, let's suppose, and I'm sure you would have done this. If you have never done this in your life, this is a high time in your life that you do this. Do the simple experiment at your own home. Pour some water in the center of your floor, small amount of water. The water will flow in which direction? Where there is a slope. But there would also be some regions in your housing floor where it would be plain, it would be flat without any slope. In that region, when you pour some water, what will the water do? Water will randomly try to find its path. If you pour excess water, it will try to randomly find its path, right? So that is where it takes a curvilinear line. So let's suppose the river here flows like this, wants to flow. Now, here, the river action basically, in order to find some speed, river will be moving somewhat like this, the river slope would be moving somewhat like this. That means many of us here, we have never visited a river in our life. How many of us are here who has seen the river only in videos and images and not in real life? I'm sure there are many of us. If we are finding it that difficult to digest that the river can take a curved path, that means we have only seen the river in pictures from our childhood days. We have never even encountered what a river looks like. And that is simply sad to know about the fact that at this point of your life, you are not even aware or you have not been familiarized with what a river actually looks like. Okay, don't wait till the Bharat Darshan Yatra of UPSC. Have these real experiences in your life. Otherwise, what is the worth of having this kind of a life? Never do that. Okay. So here, basically, river, whenever you observe the river movement always, when the slope is not significant, river tries to find its path through. And it is in that process that it forms a kind of a meandering portion. So a meander is an erosional cum depositional feature formed by the river in its mature stage. When is it formed? When water flows in a curvy, bendy path like a snake. Why? So as the river makes its way through the area that is relatively flat, it often develops these bends as it erodes its way to the path of least resistance. It tries to flow. The direction of the flow is this itself. But in achieving that direction, it takes multiple such bends, multiple such pathways. So that solves the major issue of the universe, that whether the river will move in a straight line or whether the river can indeed take a bend. And that answers our query that yes, indeed, the river can take a bend. Okay, that is possible in this universe, and that is possible on planet Earth as well. That is something that all our rivers indicate. You will not find any particular, other than the few smaller rivers in the Western Ghats, almost all the rivers that you would have heard the name about, from Indus, Ganga in the north, Brahmaputra in the north, to Kaveri, Krishna in the south. All these rivers, they form meanders at some or the other stage, right? Ganga forms very large meanders. If ever you get an opportunity, by the way, to fly from, let's say, Delhi to Kolkata, Delhi to Bhopal, Bhubaneswar, anywhere across the northern plains or anywhere across the country, if you look down, if you manage to look down, you will observe these beautiful meanders formed by these large rivers. Many of them, they create these large meanders. Now, once that is basically understood, meanders are not very deep. This meander is what? Meander is an English terminology, my dear friends. Okay, so basically, in case you have not heard about their usage, it is an English terminology that that individual has meandered away from his path. He basically means that he is moving away. Meandering means rather than following a straight path, you are moving a wavy pattern. That is what is referred to as a meander. Okay, it is something which is observed in the mature stage of the river. Now, once we have understood that the river can move in a zigzag pattern, now let us solve the problem statement that how can this be created? So, in that region, if let's suppose we are talking about this area, and let's suppose this entire distance is 1000 kilometer. Let's suppose 1000 kilometer is the entire distance. It can absolutely be possible that out of that entire stretch of 1000 kilometer, let's suppose in between that you have 100 kilometer stretch where there is an upliftment of land due to endogenic forces. Meanders can never create endogenic forces. Endogenic forces are created in the interior of planet Earth due to the residual heat which is present, where sometimes the land can get pushed up, sometimes the land can sink down as well. So as the land gets pushed up in this area, in this region, as the land starts getting pushed up, then what will be the event? What will be the consequence of it? So there can be two possibilities. Listen to this carefully. After that, fill your mind with all the kind of information that you have. As of now, listen to this carefully for 2 minutes. Now, there can only be two possibilities as the land gets pushed up. One, rate of upliftment is very high. That is, it is moving at a height of 2 centimeters every month or 3 centimeters every month. In that case, within a year, the land would have risen up by a good chunk of close to around half a meter. So that is substantial. And if the speed of the river is not much, the river will get blocked in this region itself. The river movement won't happen beyond this, assuming that the river movement is in this direction. But then, if the rate of upliftment is very slow, as is the general case with the endogenic forces, the rate of upliftment is very slow. Let's suppose the rate of upliftment is somewhere around 1 millimeter every 2 years, right? Or 1 centimeter every 20 years, something like that. So that means this entire land area has gotten uplifted by 1 millimeter. In 1 year, let's suppose it has gotten uplifted by 1 millimeter. 1 millimeter is how much? Think about it. 1 millimeter. All of you know about 1 centimeter, 1 inch. What is 1 millimeter? This much, almost negligible. Imagine that if a river is flowing here, if this is the cross section of the river, this is the water. If the and this is the flow of the river. Imagine the even in videos, if you have seen the river, even in images that you have seen the river, you understand the might of the river flow. You understand that the rivers are mighty. I'm not talking about the small nalas and the drains that move around. I'm talking about mighty rivers. So when the rivers move, they have a substantial amount of force. So imagine if there is a small upliftment of sorts of 1 millimeter, the river will find that as an obstacle in its path. What will the river do? It will immediately carry it away. It will immediately start eroding it, cutting it away. So that cutting action is what? Isn't it a form of erosion? It is a form of erosion. But in this form of erosion, river is maintaining its own height. River is not going deeper. River is maintaining its own height. Then how is it eroding? Any upliftment which is happening, the river is eroding. But then around the sides of the river, there is no action to erode it. So the sides have gotten uplifted this year by 1 millimeter, next year again 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 by 1 millimeter. Meanwhile, the river, it is eroding any upliftment. This year, again, 1 millimeter upliftment happened, the river eroded, flattened it up. So maintained its original height. Next year, again, 1 millimeter upliftment happened, river again eroded it. So maintained its height. So by maintaining its height, virtually what it is doing, it is continuously eroding its base. Wherever the upliftment is happening, it is eroding its base. So that is how the river is able to maintain its original height, whereas all around it, the land is getting uplifted, isn't it? So eventually, what is the image that it will create? Here, if you take a look at this image, all around it, the land is continuously getting uplifted, but the river is eroding its base. So at the river bed, the river erodes any kind of upliftment which happens. That is an erosional feature. Whereas around the river, there is no force which is there to erode it. So around the river, the land has risen up. Whereas where the river is flowing, it is flowing at the same height. So this appears as if the meander has been cut through this region. Otherwise, why is it that the river is not forming a gorge? Meanders are something of a mature stage. Hence, it is what is an incised meander. Is that understood? Why upliftment is taking place inside the river? Hmm. Upliftment is not taking place inside the river. Upliftment is taking place across the larger land area. Across the entirety of the land area, upliftment is taking place. The river lies just on that. Okay. If you want a fresh image, I will draw a fresh image. Try to understand this, that when we say the upliftment is happening, it is not as if this is a larger land area. Okay. This larger land area is getting uplifted. So everything which is on this land area, even if there is a cricket stadium, even if there are houses, even if there are trees, everything is getting uplifted. So if there is a river which is moving that there, even that base of the river will also get uplifted. Is that understood? It is the part of the same process, but that base is getting eroded by the river in the process. Gaurav, I am answering your question only, and then you are asking for break. So better to have the break and then ask your question in that case, or pay stress to one of the parts. Any doubts that prevail? After the break, I will move on to the next topic. Any doubts that are there, please ask it now. Can we call Grand Canyon of Colorado as incised meander? Not much, but a portion of that Grand Canyon has been created due to that uplift. That is true, Niranjan. Why erosional phenomena of river can't go below the sea level? Because the process of erosion, see, think about it. Let's suppose the entire path, entire journey, if you consider, if I can take you back to this particular slide, entire journey of the river from origin to its end ends ends into the sea, right? Let's suppose in any area the erosion has happened below the sea level. Now, will the river, in that case, will you observe the case that the river is coming from below the sea level, then rising up? Can that be the situation ever? No, right? Because movement of water cannot happen against gravity. From lower level to higher level, movement of water cannot happen. So, always it will be above the sea level itself. Example of meanders in India, you will find multiple ones of them in the region of northern plains, in the region of Peninsular Plateau. Some of the meanders are there, but River Ganga, River Yamuna, River Brahmaputra, all of them they form meanders. The silt that rivers take with them are produced due to erosion. Yes. Okay. So now we take a break and we take a 1 hour break. So we'll be back at 2:20. Rivers carry many precious stones. It is eroded from the larger rocks through which it drains through in the mountainous areas. That is where it brings about these materials. And these are largely chunks. And due to the flow of the river, the water shapes them in a kind of a shiny particle format. As they rub against the various other obstacles, the stones break, and you have the small particles which are generated. Okay, so now we take a break. We take a break for 1 hour. So we take a break till 2:20. Okay. Priya, it is not like it make a pound and then it continue to submerge in the sea. It make a pond below sea level and then it continues to submerge in the sea. No, generally does not happen. Right? Cycle of degradation generally is restricted above the sea level itself. Okay, so please understand, any place where the river will erode below the sea level, that means in some area the river will have to have an upward motion, and that is something not possible. In case you are talking about the creation of a pond, over a period of time that pond will be filled with sediments. The entire northern plain, just to give you a preview, the entire northern plains that you see now, at one point of time in our geological history, was nothing but a large pond like that which was created. And now you see deposits there. So when water starts accumulating there, it will carry deposits. Eventually, those deposits will make the way. We'll talk about it when we come to Indian geography. Yes, Kavana, if you please pay attention in the session, the PPTs and the additional reading materials are sufficient. Senthil, what is your question, my dear friend? Uh, Difference between brook and a river: brook is considered to be a smaller stream, river is larger, much larger. Senthil, I'm unable to take a look at your question. Priya, what when the upliftment happens, then in the inner earth level, the nearby soil submerges? No, no. It is not that case. When the upliftment happens, we are talking about a substantial many kilometers worth of lithospheric upliftment, right? So lower portions of the lithosphere, some portions of the mantle, they will fill up the region. So you don't have to fill it by the soil, as you see in the case of the flowering pot like that. No. Okay. So Pavni, that will be helpful if we're moving ahead. Akshay, as I told you, brook is a very smaller portion. Rivers are large, considered to be larger. Brooks and streams, these are considered to be smaller flows associated. They are much less, carry much lesser water as compared to a larger river. They are generally created they are referred to as the smaller streams in the mountainous area, which meet up with a larger river. That is what is a brook. Okay. NCRT 11, 12 have two books each: Fundamental of Physical Geography, Indian Physical. All of them are required to be studied. All the books of NCRT of 11th and 12th you need to study. Okay. So with that, let's take a break and let's meet again at around 2:20, 2:23. We'll meet. Start from the basics of class 11th, the fundamental of physical geography. From there you start, right? And then we move ahead. Okay, Senthil. Look at the topics that have been covered in the class. Take the help of the book as well. Take the help of the PPT. Okay.